Hello, welcome to Easy Maths for Everyone. With Easy Maths for Everyone, concept simplified and success amplified. Solving previous year papers is important because it helps you understand the exam pattern, identify the high priority topics and improve your time management, thereby helping in developing strategies within the limited time. Also, it helps to enhance your problem solving skills and in boosting your confidence level by reducing the exam anxiety. Also, solving papers reinforces the understanding of core concepts and highlights the areas where you need more attention and revision. My humble request to you is, rather than watching this video, do solve the paper along with me. Do pause the video after every question is displayed, and once you are done, check your answer with mine. Hope you are ready with your pen and papers. Without further ado, let's get started. The paper we are going to discuss today is the board paper for 2024-25 batch for standard mathematics, and the paper code is 30/2/1. To begin with, let's solve the sums from section A, which are MCQs carrying 1 mark each. The first question is, if 7 cos square theta plus 3 sin square theta equal to 4, then the value of theta is. Okay, let us take down the given information. 7 cos square theta plus 3 sin square theta equal to 4. We know that cos square theta plus sin square theta equal to 1. This information we can use here by splitting this 7 cos square into two values, like 4 cos square theta plus 3 cos square theta, because the total is 7 cos square theta plus 3 sin square theta equal to 4. Now I am going to remove the brackets. So 4 cos square theta plus 3 cos square theta plus 3 sin square theta equal to 4. Now I am going to group these two together and we can take a 3 common outside. So 3 into cos square theta plus sin square theta equal to 4. So this will become 4 cos square theta plus 3 into 1 equal to 4. And that can be written like 4 cos square theta equal to 4 minus 3, which is 1. So cos square theta equal to 1 by 4. So cos theta equal to root of 1 by 4. It is just 1 by 2 only. It is not plus or minus 1 by 2, because minus 1 by 2 will come only when theta is an obtuse angle. But for this grade level, we are not going to deal with obtuse angles, only acute angles. So only positive square root we are taking. So cos theta equal to 1 by 2 is the answer for cos 60. So we can replace 1 by 2 with the cos 60. That implies theta equal to 60 degree. So correct answer is option C. Let us move on to the next sum. The probability of drawing an even prime number out of numbers from 1 to 30 is. So now we have to write the sample space or the all possible outcomes together. See, we have numbers from 1 to 30. So all the possibilities will be numbers from 1 to 30. So there is 30 numbers in the list, right? And the prime numbers, list of prime numbers we will write here. Prime numbers from 1 to 30 will be 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. So these are the list of prime numbers from 1 to 30. Of course, you guys know that. And among all these prime numbers, 2 is the only prime number which is even. So let E be the event of drawing an even prime number from 1 to 30. So the favorable outcomes for our E will be just this 2 only. So n of E will be 1 because the number of elements inside the set E is only 1, right? One element is there. So n of E is 1. So probability of drawing an even prime number equal to n of E divided by n of S, which is 1 divided by 30, and option A is the correct answer. Okay, let us move on to the next sum. The quadratic equation whose roots are 7 and 1 by 7 is. Okay, now let us recall the equation to find the quadratic equation. Okay, the formula of a quadratic equation is x square minus sum of the roots into x plus product of the roots equal to 0. Now given roots are 7 and 1 by 7, right? 7 and 1 by 7. So sum of the roots is equal to 7 plus 1 by 7. Taking 7 as LCM, we get 49 plus 1 by 7, which is 50 by 7. And product of the roots will be 7 multiplied by 1 by 7, which is 1. So therefore, required equation is x square minus sum of the roots is 50 by 7 into x plus product of the roots is 1 equal to 0. See, we usually won't stop the final answer having a fraction in it, right? 50 by 7 is a fraction. We won't stop the process like this. So we can multiply both sides with the 7 or take LCM as 7 and send it to the other side. Both are same only. So let us take 7 as LCM. This will give us 7x square minus 50x plus 7 equal to 0. And cross multiplying this 7 to the other side, 7 into 0 will become 0 only. So finally we will get 7x square minus 50x plus 7 equal to 0. And this equation is given in option A. So option A is the correct answer. Let us move on to the next sum. The least number which is a perfect square and is divisible by each of 16, 20 and 50 is. So the process behind this is we need to find the LCM of these three numbers, because the least number which is divisible by the three numbers will be their LCM, right? So we need to find the LCM of these three numbers. In case if that LCM is a perfect square, that is what we are looking for. If in case that LCM is not a perfect square, then by multiplying by which prime number can make it a perfect square number, that process we have to do to find that particular number. Okay, so let us start the process. For that we need to do the prime factorization for the given three numbers. So 16's prime factorization will be product of 4 2's, right? Or else we can write it like 2 power 4 also, right? And then 20's factorization is 4 into 5 or 2 into 2 into 5, which is 2 square into 5 power 1. And then 50's prime factorization will be 2 into 5 into 5, or we can write it like 2 power 1 into 5 power 2. Okay, now we need to find the LCM for these three numbers. So LCM of 16, 20 and 50 will be, only 2's and 5's are available here as the primes. Yeah, so 2's and 5's will come in the LCM also. But what about the power? Yeah, let us look at the power of 2 in every factorization. 50 has 1 2 and 20's factorization has 2 2's and 16's factorization has 4 2's. So the maximum among all these is 4 times. So 2 power 4 we have to put here, right? And about 5, 20 has 5 one time and 50 has 5 two times. So 2 times is the maximum most occurrence. So 5 power 2 we have to put here. So the LCM of these two is the product of 2 power 4 and 5 square, which is nothing but 16 into 25, and their product will be 400, isn't it? And look at this perfect square. So this is the least number. Therefore, 400 is the least number divisible by all the three, isn't it? Divisible by 16, 20 and 50. But look at 400. 400 itself is a perfect square number only. Why? Because that is the square of 20. So we need not do factorization again and then multiplying by the missing factor, prime factor, nothing like that. Okay. So 400 itself is a perfect square number. But look at the options given here. 1200, 3600, 2400 are all the multiples of 400, right? But the least multiple will be 400 only, but that is not given in any of the options. So the options given, all the 4 options given here is not true. So 400 is the correct answer. Okay, let us move on to the next sum. The coordinates of the endpoints of a diameter of a circle are 5, -2 and 5, 2. So let us draw a circle for our understanding. So let this be the diameter, and you guys know that the center always lies on the diameter. Let this be 5, -2 and this end be 5, 2. That's what is given. So let this point be A and this point be B. So these are the endpoints of the diameter given, and they are asking for the length of the radius of the circle. So if we find the diameter's length, then radius is half of it, right? So we can easily do that. So let us find the length of AB, which is the diameter. So diameter of the circle is equal to length of the line segment AB. So AB's length will be square root of, let us take the point like x1, y1 and x2, y2 and apply the distance formula to find out the distance between A and B. It will be like 5 minus 5 whole square plus 2 minus of minus 2 whole square, which is 0 square plus 4 square. 2 plus 2 only, right? 4 it is. So this becomes root of 16, which is 4. Here the diameter of the circle is 4 units. So radius of the circle will be half of this length, right? So radius of the circle equal to diameter divided by 2, which is 4 divided by 2. The answer is 2 only. But here option A has plus or minus 2. But look at the question, length of the radius. The length can never become negative. So minus 2 cannot even be considered, right? So the correct option is just a 2 only, because length can never be negative. So option D is the correct answer. Let us move on to the next sum. The points -5, 0, 5, 0 and 0, 4 are the vertices of a triangle which is a or an, which option is true. So in order to know whether it is a right angled or isosceles or equilateral or scalene, whatever, we need the lengths of the sides. So length of AB, BC and AC we have to find out. According to the lengths we are getting, we can decide what type of triangle it is. Yeah, so let us do one by one. So I have drawn a triangle randomly. I have marked it with vertices ABC, and the given vertices I have taken like this. So let us find the distance between A and B now. So AB equal to root of, so if I take point A and B for reference here, I can give this like x1, y1, this like x2, y2. So this length will be x2 minus x1 whole square plus y2 minus y1 whole square. So this will be root of minus 5 minus 0 whole square plus 0 minus 4 whole square. This will be root of minus 5 whole square plus minus 4 whole square, which is equal to root of 25 plus 16, which is root of 41. Okay, and let us find the distance between B and C. I am going to call C point as x3, y3, okay, which is 5, 0. Okay, now BC's distance will be obtained by doing x3 minus x2 whole square plus y3 minus y2 whole square. Okay, and that will be root of 5 minus of minus 5 whole square plus 0 minus 0 whole square, which is root of 5 plus 5 whole square. 0 minus 0 is 0 only, so leave it. So this will be like root of 10 square, which is root of 100. Okay, and then let us do AC's length. AC's length is like x3 minus x1 whole square plus y3 minus y1 whole square, which is equal to root of 5 minus 0 whole square plus 0 minus 4 whole square, which is again root of 25 plus 16, which is equal to root of 41. Okay, so these are the length of the sides we have obtained. Okay, so now obviously this is not equilateral triangle because only two sides are equal in length and the other one is different. Okay, so equilateral is not at all possible. Scalene is also not possible because we are not getting different numbers for all the three lengths. So scalene is also not possible. Now by seeing we are guessing this is isosceles triangle, but we have to confirm whether it is right angled or not. But obviously root of 41 whole square plus root of 41 whole square is not equal to root of 100 whole square. So what we are checking here, sum of the squares of the smaller sides is not equal to square of the larger side. So Pythagoras rule is not satisfied here. So right angled triangle is also not possible. So it is only isosceles triangle. Okay. So let us move on to the next sum. In the given figure, RS is a tangent to the circle at the point L and MN is a diameter. If angle NML equal to 30 degree, then angle RLM is. Okay, now we have to do a small construction here. Let us join L and N. So what we can say about this? See, Mn is a diameter and L is a point on the circumference of the circle, right? So when we join the end points of the diameter to a point on the circumference of the circle, we always get an angle 90 degree. So angle MLN is 90 degree. How do you know that? Because angle in a semicircle is 90 degree. We know that already. So this is 90 degree. Now I am drawing only the triangle we have here, that MLN triangle. Okay, here it is 30 degree given and this is 90 degree, we already know that, and I want to know what is this angle. We can easily do that by applying angle sum property. So angle LMN plus angle MLN plus angle MNL equal to 180 degree by angle sum property. That implies 30 degree plus 90 degree plus angle at N, all of them add up to 180 degree. That implies 120 degree plus angle MNL equal to 180 degree. That implies angle MNL equal to 180 minus 120, which is equal to 60 degree. So just we got that MNL angle equal to 60 degrees. Okay, now you will be wondering why would you need this angle, right? So let us see why we need that angle. See, we know that if there is a circle, okay, and if this is the tangent to the circle, if this is the center of the circle, And if we have a chord of the circle, okay, and we want this angle, okay, if we join the end points of the chord with another point on the other segment of this circle, suppose if I join like this, then this angle is called as angle in the alternate segment, right? And we know well that whatever is this angle's value will be the same like this angle, right? That is the angles in the alternate segment are equal. So that is called as the alternate segment theorem, right? So now how is that getting applied here? Yeah, let us see. This is the circle and RS is the tangent and L is the point of contact of the tangent and the circle, and this LM is a chord. Okay, this LM is the chord and this angle they are asking us. So this LM chord's two endpoints, if we join with any point on the other segment of the circle, that is this end point. So this angle, whatever is the angle at N, will be the same like this RLM angle, right? And just a while ago we found MNL angle as 60 degree. So this angle will also be the same 60 degree only. So option B is the correct answer. Okay, let's go to the next sum. In the given figure, PQ parallel to BC, if AP by PB equal to 4 by 13 and AC equal to 20.4 centimeter, then the length of AQ is. So we have to apply the basic proportionality theorems concept here. Yeah, what we have learnt in that, we know that if PQ parallel to BC, then AP by PB equal to AQ by QC, isn't it? This we know by basic proportionality theorem or BPT. Okay, so that implies AP by PB's value is given like 4 by 13. So 4 by 13 equal to AQ by QC. See, I am going to take AQ like X. So this total length AC is given to be 20.4 centimeter, right? So QC's length will be 20.4 minus X, isn't it? So we can write like that. So I am going to replace that now. So 4 by 13 can be written as X divided by 20.4 minus X. Right? Now this is more like a linear equation. We can cross multiply and solve it to obtain the value of X. So let's do that. That implies 4 into 20.4 minus X equal to 13 into X, 13X. So that implies 4 into 20.4 will be 81.6 minus 4 into X is 4X equal to 13X. Now we are taking this 4X to the other side. So we get 81.6 equal to 13X plus 4X, which is equal to 17X. So if we divide by 17, 81.6 divided by 17 equal to X. So the answer is 4.8, yeah, which is available in option D. So that's the correct answer. Let's move on to the next sum. Which of the following statements is incorrect? We have to identify the statement which is not correct. So let us try to eliminate the correct options. Okay, so two congruent figures are always similar. Congruent figures means when the shape and the size both are equal, that is when we call congruence, right? And when only the shape is same but the size is not same, that is when we say it is similar type, right? So two congruent figures are always similar. This is true only, true statement only. So this we cannot take because we want a false statement. And look at the option C. Two equilateral triangles are always similar because whatever be the equilateral triangles, the sides will be the same, right? All the sides will be the same. So the proportionality will always be coming there. And equilateral triangles will have 60 degree at every vertex. So all the angles will be always same. So two equilateral triangles are always similar is also a true statement, but we don't want a true statement here, so ignore this. And two similar triangles need not be congruent. This is also correct because similar triangles won't be equal in size. So congruency comes only when the size and shape both are matching, but similar triangles will match only in the shape, right? The size won't match. So not congruent is also correct statement. So we don't want the correct statement now. And look at the option given in B. A square and a rhombus of the same area are always similar. This is not at all true. Okay, this is not at all true because square has all the four sides equal. Rhombus also has all four sides equal. That is okay. But what about the angles? Square has all the angles as 90 degrees, but rhombus won't have all the angles equal. Only the opposite angles are equal. So we can't say the angles are equal in both the figures, right? Only when the angles are matching, we can consider about the similarity. When the angles won't even match, we can't even think about the similarity. So B is the false statement. That is what we are looking for. So option B is the correct answer. Okay, so let us move on to the next sum. The sum of the exponents of prime factors in the prime factorization of 4004 is. So first we have to do 4004's prime factorization and we have to write it as a product of primes, and whatever are the powers of those primes, those are called as the exponents of the prime factors, right? So after the prime factorization, whatever powers each prime factor is having, we have to take all the powers in them and we need to add them together. That is what they are asking as sum of exponents. Okay, so let us start the process by factorizing 4004. So 4004, we can start with the 2 and then again with the 2. Okay, this is divisible by 7 now. Okay, 7 one time balance 3, 30. 7 4 times 28 balance to 21. 7 3s are 21. And now we can try with 11. Okay, 11 one time balance 3. 11 3 times 33. And 13 is also a prime number. We can't proceed further. So 4004 can be written as the product of primes like this. And if there is any prime getting repeated, we have to put a power there. So 2 power 2, 7 power, only 1 7 is there, only 1 11 is there, and only 1 13 is there. Okay, what are the exponents we have now? The numbers in the powers, right? So these are the numbers in the powers. Now we need to add all of them. And their total is 5. So answer is 5. So option A is the correct answer. Okay, let us move on to the next sum. Sum number 11. In a cricket match, a batsman hits the boundary 7 times out of the 42 balls he plays. The probability of his not hitting a boundary. So, first of all, let us find out what is the probability of the batsman hitting a boundary. Okay, so favorable outcomes will be 7. Why? Because 7 times the batsman hits a boundary. So 7 is the favorable outcome. How many balls the person have faced? 42 balls, right? So total outcomes will be 42. Therefore, probability that the batsman hitting a boundary will be favorable outcomes divided by total outcomes, which is 7 by 42. We can simplify this. 1 by 6 is the answer for this. Now, not hitting a boundary is the opposite of this, right? So, we call it like a complementary event, right? So, therefore, probability that the batsman not hitting a boundary will be equal to 1 minus probability of the batsman hitting a boundary, right? How do we know that? Because probability of the complementary event will be equal to 1 minus probability of the event. So we are applying that concept only. So 1 minus 1 by 6, and we have to take 6 as LCM. So 6 minus 1 by 6 will be 5 by 6. So option C is the correct answer. Okay, let us move on to the next sum. If a large circular pizza is divided into 5 equal sectors, then the central angle of each sector will be, suppose this is the circular pizza, and suppose if this is the center, and we are cutting this equally into 5 sectors. Okay, so for example, if I do like this, so this is number 1, this is number 2, this is number 3, and this is number 4, and this is number 5. So there are 5 equal sectors we have drawn, okay, and we need to find the central angle of each sector. Okay, one thing we have to understand is, if the sectors are equal, that means they all have the same central angle. Why? Because we are splitting it equally into 5, means these arcs will be, right, all these 5 arcs will be same in length. So when the arcs are same in length, the angles that they make at the center of the circle also will be equal to each other. Suppose if this is theta, then each and every angle will be the same theta only. Okay, so all are thetas now, but we know that angle at the center of the circle is always 360 degree. So we can add all the thetas together, and that will always give us 360 degree, because angle at the center of the circle. So sum of all the thetas will be 5 theta, and that is equal to 360. So theta will be equal to 360 divided by 5. So 5 sevens are 35, balance 1 10, 5 twos are 10. So each central angle is supposed to be 72 degrees. So option D is the correct answer. Let us move on to the next sum. If sine 30 into tan 45 degree equal to secant 60 degree divided by k, then the value of k is, we need to put the values of these angles, particular angles. We already know their values. What are they? Sine 30's value is 1 by 2, and tan 45 degrees value is 1, and secant 60's value is 2, isn't it? So let us take the given equation. Sine 30 into tan 45 equal to secant 60 divided by k. That implies 1 by 2 into 1 equal to 2 divided by k, right? That implies 1 by 2 into 1 is 1 by 2 only. 1 by 2 equal to 2 by k. Do cross multiplication. K into 1 equal to 2 into 2. That implies k is equal to 4. So option A is the correct answer. Let us move on to the next sum. Sum number 14. The line represented by the equation x minus y equal to 0 is, what type of line we will get? Okay, we have to tell it. So one thing we have to understand is, if this is the coordinate axis, any line which is parallel to x axis, either that side or this side, will be of the form y equal to some b, some constant. Okay, and this equation x minus y equal to 0 is of the form x equal to y or y equal to x, which is not y equal to some constant, right? The same way, if we have the coordinate axis, any line which is parallel to y axis will be on this side maybe, or that side. Okay, in both the cases, the equation of these lines will be of the form x equal to some constant. Okay, and this is also not of the form, because x equal to not a constant, it is equal to another variable. So this is also not correct, this is also not correct. Let us think about the option given in D. passing through the point 3, 2. Suppose if a line passes through a point, then if I put the point's value in that equation, replacing for x and y, I should get the equation satisfied. I mean, my LHS's answer and RHS's answer both should be matching with each other. That is when I can say that line passes through that particular point, right? So, if I take 3, 2, then 3 minus 2 should be equal to 0, if that is a valid thing. Okay, but 3 minus 2 is equal to 1, which is not equal to 0, right? So for the LHS I am getting 1, for the RHS they have given 0, both of them are not same. So 3, 2 is not a point on the given line, okay? So y equal to 0, or you can say the line is not passing through the point 3, 2. Both are same only, right? So this is also not valid. So passing through the origin is the only option, and you can make sure about that also by putting x equal to 0 and y equal to 0. So if I put 0, 0 in the particular equation given, then I will get 0 minus 0 equal to 0. So LHS is also 0, RHS is also 0. So the equation is satisfied when I put origin. So origin should lie on the particular line. So that is our final answers. Option C is the required answer. Okay, let us move on to the next sum. The 10th term of the AP 5, 19 by 4, 9 by 2, 17 by 4, etc. First of all, if you want to find the nth term of the AP, we should be aware of the first term and the common difference of the AP, right? So our first target is to find them, and first term, if we call it like A, it is 5, right? So common difference will be equal to term 2 minus term 1, or term 3 minus term 2 also, right? Everything will be give you the same common difference only. So we can take any 2 points, any consecutive points. So 19 by 4 minus 5 we need to find out. So taking 4 as LCM, we have 19 minus 20 by 4. So this is minus 1 by 4. So common difference is minus 1 by 4, and the first term is 5. So since we know them, now we can find the 10th term of the AP. So term 10 equal to A plus 10 minus 1 into D, right? That is common difference is D, right? So A plus 9D we have to do. So that will be 5 plus 9 into minus 1 by 4. This will be 5 plus minus 9 by 4, or we can write it like 5 minus 9 by 4. Again we have to take 4 as LCM. This will become 20 minus 9 by 4, which is 11 by 4. And 11 by 4 is given in option A, and that's the correct answer. Let us move on to the next sum. If minus 4 is a 0 of the polynomial p of x equal to x square minus x minus of 2 plus 2k, then the value of k is, see, one thing we have to know is, if they give some number as a 0 of the polynomial, then when I replace x with that number given, the polynomial becomes 0 at that particular point, right? That is the meaning of the 0, right? So minus 4 is a 0 of p of x, that is given, right? That implies p of minus 4 should become 0. Yeah, that implies when I replace x with a minus 4, I can find p of minus 4, right? So that will be minus 4 whole square minus x value itself is minus 4. Yeah, minus of 2 plus 2k should become 0. Okay, let us solve this further. Minus 4 square is 16. Minus of minus 4 is plus 4. This minus we can take inside. Minus 2 minus 2k equal to 0. That implies 20 minus 2 is 18. 18 minus 2k equal to 0. That implies 18 equal to 2k. That implies 18 divided by 2 will be the value for k. That implies 9 will be the value of k, and that is given in option B. That's the correct answer. Let us move on to the next sum. the equation of a line parallel to the x-axis and at a distance of 3 units below the x-axis is. Okay, one thing we have to understand is just a while ago in another sum I told you that any line parallel to x-axis will have its equation of the form y equal to sum b, right? Here at a distance of 3 units below the x-axis means that line should be like this, okay, below the x-axis, and the distance between the x-axis and this particular line is given like 3 units. So this point should be minus 3. Why? Because this is in the negative side of y-axis, so that point will be minus 3. So 0 comma minus 3 will be that point. So how can I write this line's equation? Y equal to minus 3. That's how we have to write it, right? So y equal to minus 3 is given in C option. So that's the correct answer. Let us move on to the next sum. The HCF of 40, 110 and 360 is, so we need to do prime factorization for all the numbers and find out the HCF. So let us do 40's prime factorization first. So it will be like 2 into 2 into 2 into 5, right? 2 2s are 4, 4 2s are 8, 8 5s are 40. So these are the prime factors for 40, and we have to do for 110 separately only. Let us do with the 2, 2 5 times, balance 1, again 5 times. We can do with the 5, 11 times, that's the end. And for 360, we can start with the 2, 2 18 times, another 0, and then 90 times, and then 45 times, and then 5 9 times, and 3 3 times. So if we write the factors in the ascending order of the primes, then 110's prime factorization is 2 into 5 into 11, and 360's prime factorization will be 3 2's and 2 3's and 5. So these are the prime factors we have, right? And what all the common factors every number's prime factorization is having, we have to round off those numbers. So 2 is available in all the factorizations, only 1 2 is common, and all of them have a 5 common and nothing else, right? So only these two are the common factors. So HCF of 40, 110 and 360 will be product of the common factors, correct? So that is nothing but a 10, and the answer is given in option D. That's the correct answer. Let's move on to the next sum. The assertion and reason based sum. Common difference of the AP 5, 1, minus 3, minus 7, etc. is 4. Okay, let us take the given AP. Given AP is 5, 1, minus 3, minus 7, etc. So its common difference will be obtained by subtracting term 1 from term 2, right? So term 2 minus term 1 or term 3 minus term 2, whatever we can do. So 1 minus 5, which is coming as minus 4, but they are saying common difference is 4. So this statement seems like a false statement, right? And let us look at the reason. Reason are common difference of the AP A1, A2, A3, etc. AN is obtained by D equal to AN minus AN minus 1. That means the term minus its preceding term, right? If we do that, we will obtain the common difference, which is perfectly correct. That's how the common difference is defined. So reason seems like a valid statement, true statement. Okay, so what is the conclusion here? Let us see. The assertion is being false and the reason is being true. So when this situation comes, which option we will choose here? Option D, right? So we have to choose option D as the answer, right? Now let us move on to the next sum. Assertion is given like the pair of linear equations px plus 3y plus 59 equal to 0 and 2x plus 6y plus 118 equal to 0 will have infinitely many solutions if p equal to 1. And let us read the reason now. If the pair of linear equations px plus 3y plus 19 equal to 0 and 2x plus 6y plus 157 equal to 0 has a unique solution, then p not equal to 1. Okay. So, one thing we have to understand is the condition for infinitely many solutions. So, the lines will have infinitely many solutions if a1 by a2 equal to b1 by b2 equal to c1 by c2. If we take first line like a1x plus b1y plus c1 equal to 0, and second line like a2x plus b2y plus c2 equal to 0, then this condition should be satisfied. Only then we can say the line will have infinitely many solutions, right? Now let us check what is our a1, b1, c1, everything. In the given assertion, we have a1 equal to p and b1 equal to 3 and c1 equal to 59. And in the next line given in assertion, we have a2 equal to 2, b2 equal to 6 and c2 equal to 118. Okay, now let us put them here. That implies p by 2 equal to 3 by 6 equal to 59 divided by 118. This should always be true. If I take p equal to 1, let us see what happens. 1 by 2 equal to 3 by 6 is also 1 by 2. 59 by 118 is also 1 by 2 only. So, if p equal to 1, all of these fractions will be equal to each other, which is perfectly correct. So, assertion is true only. Right? Now, let us see the next pair of lines given in reason. Px plus 3y plus 19 equal to 0 and 2x plus 6y plus 157 equal to 0. We have to solve them. They are saying these equations will have unique solution when p is not equal to 1. Okay. Now let us see. The lines will be having unique solution when a1 by a2 is not equal to b1 by b2. So, according to the lines given in reason, a1 is equal to p and b1 is equal to 3 and a2 is equal to 2 and b2 is equal to 6. Okay. So, now when we put the values in this, we will have p by 2 not equal to 3 by 6. Okay, that implies p by 2 not equal to 1 by 2. When we multiply both sides with the 2, we should get p not equal to 1. That is the given condition. When p is not equal to 1, they will have a unique solution, which is also true only, perfectly correct. But look at the assertion and the reason given. They don't have any connectivity between them, right? One statement is saying about the infinitely many solution case and the other thing is saying about the unique solution case. So they don't have any link between them. So we can say assertion and reason both are true, but the reason is not the correct explanation for this assertion. So if that is the case, we have to choose option B for our answer, right? So let us write the final conclusion here. So both A and R are true, but R is not the correct explanation for A. So we have to choose option B here. That's the answer. Let us solve section B, very short answer type, carrying 2 marks each. Sum number 21. If P and Q are zeros of the polynomial P of y equal to 21y square minus y minus 2, then find the value of 1 minus P into 1 minus Q. Right? So, we are going to take the given polynomial Okay, so given P of y equal to 21y square minus y minus 2, sum of the zeros equal to, given that p and q are the zeros, right? So sum of the zeros will be p plus q, that is going to be minus b by a. Now we need to compare the given polynomial with the standard form, which is a y square plus by plus c, because the variable here is y. So this is our standard form. Now when we compare this and the given equation, we can say a is 21 and b is minus 1 and c is minus 2, isn't it? So p plus q equal to minus b by a. Now b's value is minus 1, so minus of minus 1 divided by a is 21, and this will become 1 by 21, right? And now we are going to find out product of the zeros also. So product of the zeros will be P into Q, isn't it? So P into Q's formula will be C by A. For this sum, C is minus 2 and A is 21. So product of the zeros is minus 2 by 21. So we need these two values. Okay. Now we need to find the value of 1 minus P into 1 minus Q. That's the question. So let us take what is to be found. So 1 minus P into 1 minus Q. We are going to simplify this. Why we need to simplify this? Because we don't know what is the exact value of P and Q, but we only know that sum of P and Q and product of P and Q. So this way we can't find the answer, but we can do some simplification so that the already found things will help us to find the answer. Okay, so let us do that. When I multiply one binomial by another binomial, what I can do is 1 into 1 minus q, okay, minus p into 1 minus q. This is how we will multiply them, right? And this will be 1 minus q minus p plus pq, correct? Now what I am planning to do is, this 1 I am keeping as it is, and out of these two I am taking a minus outside, and this will become q plus p, and this pq I am keeping the same. Okay, and this q plus p I can rewrite like p plus q also, because addition of items is commutative, right? We can write however we need it. So now I know what is p plus q and what is pq, so I can put them here. So that will be 1 minus p plus q's answer is 1 by 21 plus pq's answer is minus 2 by 21. So when we remove the brackets everywhere, we get 1 minus 1 by 21 minus 2 by 21, and this will become 1 minus, if I take the minus common, I'll get 1 by 21 plus 2 by 21, and this can be written like 1 minus 3 by 21, and we can take 21 as the LCM here, and the numerator becomes 21 minus 3, and this will become 18 divided by 21, and that can be simplified with a 3, right? So 3 6 are 18 and 3 7s are 21. So the value of 1 minus p into 1 minus q is equal to 6 by 7. Okay, that is the answer. Let us move on to the next sum. Sum 22 has two choices. The first one is, in the given figure, the shape of the top of a table is that of a sector of a circle with center O and angle AOB equal to 90 degrees. If AO equal to OB equal to 42 centimeters, then find the perimeter of the top of the table. Okay, so let us try to understand. There is a table which is in the shape of a sector. Okay, and AO and OB are nothing but the radius of the circle so formed, which is given as 42 centimeters. Now we need to find the perimeter of the top of the table. So what do you mean by perimeter? Yeah, so perimeter means starting from a point and going all the way, tracing the curve fully, completely, and coming back again to the same starting point. Yeah, if I start here, it will be like tracing this full curve and then coming back to the same starting point O, right? So if you think about that, the perimeter will be, so we have to find the arc length, and then there are two radius. So this is one radius, this is also another radius, this is O, this is A, this is B, and this is the major arc AB. If we add all these lengths together, we will get the perimeter of the full table. Okay, so now we need to find out this length of the arc. Okay, so here is the center O. Here it is given as 90 degree. I don't need 90 degree now because that major arc will subtend a different angle on the other side, right? I need the black color marked angles value, which is a reflex angle, right? So how can I find it? The total angle subtended at the center of the circle is 360 degree. So this side is 90 degree. So the other side will be 360 minus 90, which is 270 degree, isn't it? So I need to find the length of the major arc which subtends 270 degree at the center of the circle. Okay, and then after finding that arc length, I need to add 2 times the radius, and that will give me the entire perimeter of the table. Okay, now let us do that. Length of the, let me call a point here. Okay, just to mention the arc, we need 3 letters. So I am taking as a letter C, taking a point C on the arc AB. So length of arc ACB equal to 2 pi r theta by 360. This is the formula, right? So here I know r equal to 42 centimeter. That is given in the sum. And theta is given to be, found to be 270 degrees. Right? So this will become 2 into 22 by 7 into radius is 42 and theta is 270 degree whole divided by 360. Okay, so now if we cancel here 7 6 times 42 and 1 0 we can cut here, and then 6 1 time 6 6 are 36 and 2 and 6 we can cut, 2 1 time and 2 3 times, and 3 and 27 we can cut, so 3 1 time 3 9 times 27. So the final value for this is, we are having 22 into 9 here, 198 centimeter. Okay, so that is the length of the arc ACB. We need to find the perimeter now. So perimeter of the top of the table equal to length of arc ACB plus OA plus OB. Correct? So this will be equal to 198 plus OA and OB both are 42 only. So we need to add all of these. So the answer for this is 282 centimeter. Right? So that is the perimeter of the top of the table. So you have to write the conclusion here. Perimeter of the top of the table equal to 282 centimeter. That's the end of this sum. Let us move on to the other part of the same sum. In the given figure, three sectors of a circle of radius 5 centimeter, making angles 35 degree, 50 degree and 95 degree at the center are shaded. Find the area of the shaded region. So here we are given three different sectors. Okay, so let us name them like sector number 1 and sector number 2 and sector number 3. So find the area of the shaded region means we need to find the area of each of these sectors and we need to add all their areas together, right? That's the task here. So we have to use the formula for area of the sector and we have to do it. See, the central angles are already given and the circle's radius is also given. So it is a direct application type only. We can easily do that. So let us mention the formula which we are going to use here. Area of a sector equal to pi r square theta divided by 360 degree. In this sum, r is given to be 5 centimeter and value of theta will be different for everything, right? So we will call them like theta 1 and theta 2, theta 3. Okay, so theta 1 will be 35 degree, theta 2 will be 50 degree and theta 3 will be 95 degree. So let us see how we can find the areas of each of them. Area of sector number 1 equal to pi r square theta 1 divided by 360, which is equal to, let us not put the value of pi now. Okay, let us keep it as it is. I have a reason for doing this. I will tell you later. Pi into r is 5, so 5 square. Theta 1 is 35, so 35 divided by 360 and this will be equal to pi into 25 into 35 divided by 360 and that is equal to 875 pi divided by 360. We will simplify later. Let it be as it is. And area of sector number 2 is equal to pi r square theta 2 divided by 360, which is equal to pi into 5 square into 50 divided by 360. This is pi into 25 into 50 divided by 360 and that will be equal to 1250 pi divided by 360. And the third sector's area of sector 3 equal to pi r square theta 3 divided by 360, that is pi into 5 square into 95 divided by 360. This is pi into 25 into 95 divided by 360 and that will be 2375 pi divided by 360. Okay, now we need to find the total area of all the sectors, right? That can be obtained by adding all the three areas. Yeah, so that will be equal to 875 pi by 360, which is the area of sector 1, and 1250 pi divided by 360, which is area of sector 2, and 2375 pi by 360 is the area of sector 3. So we are adding all of them. So 360 can be taken as the LCM and the numerator will be just added up. Okay, and now we can take pi common outside and then add all the numbers inside. When we add all the three numbers inside, we get 4500, right? So this will be pi into 4500 by 360. Now we can try cancelling 4500 and 360. So 1 0 will be cancelled and we can cut with the 9, right? So 9 4 times here 9 5 times and a 0, and again we can cancel with a 2. So finally we are having pi into 25 by 2, and pi's value we can put now. So 22 by 7 into 25 by 2. So this will be 2, we can cut here 2 11 times. So this will be 275 divided by 7. Dividing 275 by 7, we get 39.285, which can be rounded off to 39.29, and the unit for this is centimeter square. Right? This is the total area of all the shaded regions, and that's the end of the sum. Let's move on to the next sum. Sum number 23. If tan A equal to root 3, where A is an acute angle, then find the value of sine square A by 1 plus cos square A. So let us take the given thing. Tan A equal to root 3, this is given, and they are saying A is an acute angle, right? So any angle which is less than 90 is called as an acute angle. So we know from the table of trigonometric ratios that tan 60 equal to root 3, right? So that we can apply here. Tan A equal to tan 60. We know this already. That implies A is equal to 60 degree. So this value of A we have to use in finding sine square A by 1 plus cos square A. So let us start finding the value. Sine square A by 1 plus cos square A's value will now be equal to sine square 60 degree divided by 1 plus cos square 60 degree, and the value of sine 60 degree is root 3 by 2, and the value of cos 60 degree is 1 by 2, right? So this will be root 3 by 2 to the power 2, because sine 60 is root 3 by 2. Here we have sine square 60. So here this will be 1 plus 1 by 2 whole square, and we need to simplify this further, and that will be equal to root 3 square by 2 square will be 3 by 4 divided by 1 plus 1 by 2 whole square will be 1 square by 2 square, which is 1 by 4, and now the numerator is 3 by 4 as it is. In the denominator we have to take 4 as LCM. So this will become 4 plus 1 by 4, isn't it? So this will become 3 by 4 divided by 5 by 4. And of course we can flip the fractions and multiply them. So 3 by 4 into 4 by 5. This will give us 3 by 5 as the answer. Okay, and that's the answer. Let's move on to the next sum. Sum 24 has two choices. The first one is, in the given figure, D is a point on the side BC of triangle ABC such that angle ADC equal to angle BAC. Show that CA square equal to CD into CB. Actually, we need to prove there is a similarity between two triangles here. And what are those triangles? They are ADC triangle and ABC triangle. So for that reason, I have drawn both the triangles separately here, and one angle being equal is already given by them. So angle ADC, this angle, is equal to angle BAC, this angle at A. So I have marked it already. What is the other pair of angles which are equal to each other, which you know by default? Look at this angle at the vertex C. This C vertex is the same common vertex for both the triangles we have drawn here, right? So naturally that will have the same angle. So whatever is angle ACD will be the same angle ACB. So two angles are made equal to each other, and that's enough to prove there is a similarity between the triangles. Let us see how to prove it. In triangle ADC and triangle BAC, angle ADC equal to angle BAC. This was already given. That's the reason. And also angle ACD equal to angle ACB, since C is a common vertex, right? C is a common vertex, so angle will be the same angle. Therefore, by AA similarity criterion, triangle ADC is similar to triangle BAC. Make sure you have written the order of the letters in the correct position, which I always insist, because once the order gets disturbed, the ratio which you are going to write will become disturbed. So make sure you have written them in the correct order. See, angle D and angle A both are equal. So D and A are made in the center position. Yeah, and then angle C and angle C in both the triangles are equal. So C is placed in the same position, the third position, and the remaining letter which we have not taken is placed in the first position. So this is the perfect order we have placed them. So now we can write the sides proportionality. So therefore the corresponding sides will be proportional, right? So what are the corresponding sides which are proportional here? Let us write them. AD side from the first triangle and BA side from the second triangle are proportional to each other, and DC and AC are proportional, and AC and BC are proportional, right? So we have to follow the correct order of the letters, taking two letters at the time. Taking all the three sides of both the triangles, we have to write this proportionality. You guys very well know this, and you have to make sure that sides of the same triangles are supposed to be either in the numerator or in the denominator. We should not mess up that. So make sure about that. Now we will see what we need to prove here. CA, CD, CB, these three sides we are going to take for this proof. So this ratio and this ratio we are going to take. Only these two are enough, because AD and BA sides are not there in this proof, right? So let us leave that fraction. So we are going to take these two ratios separately. So DC by AC equal to AC by BC implies, by cross multiplication we have DC into BC equal to AC into AC, and that can be written like DC into BC equal to AC square. AC square or CA square both are the same side only. So that can be written like they have given also, CD into CB equal to CA square, which is the same meaning only. So that is the thing we need to prove. Let us move on to the next choice of this. Sum 24b, in the given figure, OA into OB equal to OC into OD. Show that angle A equal to angle C and angle B equal to angle D. Okay, now let us see how to prove that. Let's take the given thing. For our understanding, I have drawn the triangle AOD and COB separately. Okay, and we are going to prove that these two triangles are similar. By the similarity, we can easily say that the corresponding sides are proportional as well as the corresponding angles are equal also, right? So the corresponding angles being equal will be helping us in this case. So let us see how to prove that. So let us start from the given thing. OA into OB equal to OC into OD, correct? So what we are going to write now is OA divided by OC equal to OD divided by OB. So, hope you have understood. We are taking OC to the left side and OB to the right side. So, they will go to the respective denominators, and this is what we are having. Okay. So, what do you mean by this? The sides OA and OD from the smaller triangle and the sides OC and OB from the larger triangle are proportional to each other, right? And what about this angle at O? Look at the main picture given to us. See, this angle and this angle are always equal. Why? How do you know that? Because they are vertically opposite angles. They are always equal to each other only. So, OA by OC equal to OD by OB. Also, angle AOD equal to angle COB. How do you know that? You have to always mention the reason in the side, since vertically opposite angles. Okay, so therefore by SAS similarity criterion, triangle, watch out for the order of the letters. AOD is similar to triangle COB. Okay, because AO side and CO side are proportional to each other. I have kept both the letters in the same positions. Angle at O is to be equal. So, O is supposed to be in the same position, and the same way OD and OB sides are proportional. So, they are supposed to be in the same position, right? So, that's how this order of letters were made. Okay. Now, because of this similarity, the corresponding angles will be equal, right? So, that aspect we can use here. Yeah. We know that corresponding angles in both triangles are equal. So, that implies angle at A is equal to angle at C, because A and C are in the correct positions, and angle at B and angle at D should be equal to each other because they are in the corresponding positions. So, that is what they are asking us to prove, right? That is already proved. So, that's the end of the sum. Let us move on to the next. Sum 25. At a point A on the diameter AB of a circle of radius 10 cm, tangent XAY is drawn to the circle. Find the length of the chord CD parallel to XY at a distance of 16 cm from A. So, let us try to understand the scenario. There is a circle given whose radius is 10 cm. Okay, and there is a diameter AB drawn to the circle. Okay, so BA is the diameter, and at the point A we are drawing a tangent which is XAY. Okay, and they are saying CD chord and XAY tangent both are parallel to each other. So, it is given that the distance between CD chord and XAY tangent is 16 centimeters. So, what do you mean by that? AP distance equal to 16 centimeter. Okay, so using this, you have to find the length of the chord CD. Okay, so let us see how to do that. So, let us start with the given thing. Given AP equal to 16 centimeter. Okay, and see the radius is 10 centimeter, right? So, OA is nothing but the radius of the circle. So, OA is 10 centimeter. And now I want to know the distance between P and O. Okay, or OP. Yeah, let us see how to find it. Look at this picture. So, this length is 16 centimeter and this length is 10 centimeter. So, what about OP? OP will be 16 minus 10, right? So, that will be 6 centimeter, right? Let us write it now. Okay, and what else is given? XY parallel to CD. Okay, so look at the second picture I have drawn here, this one. Okay, we need to understand something here. When CD and XY are parallel to each other, AP is a transversal which is touching both the parallel lines, right? So there should be 90 degrees here, right? How do we know that? Because we know that radius and tangent always make 90 degree between them. OA is the radius, XY is the tangent. So OA and XAY will make 90 degree with each other. So that we know that this is 90 degree, and this CPO angle is the alternate interior angle. Since CD and XY are parallel, alternate interior angles will always be equal to each other. Because this is 90, this is also 90. So basically this if we connect this CO and DO, we will get two right triangles formed, right? So I need only one right triangle currently. So I am taking CPO right triangle, and we know OC is the radius, right? Because C is a point on the circle, O is the center of the circle. So OC will be the radius, which is always 10 centimeter given. OP is length, just a while ago we found it, that is 6 centimeter. And CP is the missing side of the right triangle, which we can always find using the Pythagoras theorem, right? So that's what we are going to do now. So let us see how. We have to say that there is a 90 degree here. Okay, so XY parallel to CD, that implies angle CPO is equal to angle YAO, since alternate interior angles, but angle YAO equal to 90 degree, since angle between radius and tangent at point of contact is 90 degree. That's why. So that implies angle CPO is also equal to 90 degree, right? Now we are going to take the right triangle CPO and apply Pythagoras there. In right triangle CPO by Pythagoras theorem, OC is the hypotenuse, right? OC square equal to CP square plus OP square. So 10 square equal to CP square is unknown. This is 6 square. So 100 equal to CP square plus 36. So CP square will be 100 minus 36, which is 64. So CP will be root of 64, which is 8. Not plus or minus 8. This is the length. So just plus 8 only. Now CP's length we have found, right? And we very well know that the perpendicular from the center bisects the chord, right? By that theorem, since OP is the perpendicular, because there is 90 degree at P, so the perpendicular from the center is bisecting the chord at P, right? So that means CP and PD both will be having the same length, right? So that implies CD is also equal to 8. This is also 8, that is also 8. Now we need the length of the chord CD. So therefore length of CD is equal to PC plus PD, which is equal to 8 plus 8, which is 16 centimeter. Okay, and that is the end of the sum. Let us move on to the next. Let us solve section C, short answer type questions carrying 3 marks each. Sum number 26 has two choices. The first one is prove that the parallelogram circumscribing a circle is a rhombus. Okay, so what is given? There is a parallelogram and there is a circle inside the parallelogram. Okay, the parallelogram is circumscribing the circle, means the all four sides of the parallelogram is touching the circle. Okay, and we need to prove that in case if there is a parallelogram in this way, that parallelogram is supposed to be a rhombus, right? So I have drawn the figure here. Let ABCD be the required parallelogram. Let that parallelogram touch the circle at the points PQ, RS. Okay. Now let us see how we can prove this. And we are going to use a theorem here. The theorem will be length of tangents drawn from an external point to a circle are of equal length. Okay, let us write this. Always whenever we are using a theorem, we need to mention the statement without fail. Okay, so let us do that. So we know that length of tangents drawn from an external point to a circle are equal. So if we treat this point A as an external point and this AS and AP as the tangents drawn to the circle from this point A, then AS and AP both are supposed to be equal in length. So AS and AP will be equal in length, right? The same way, if we take B as an external point and BP and BQ as tangents drawn to the circle, then BP and BQ should be same in length. Same way, CQ and CR are supposed to be equal in length. DS and DR are supposed to be equal in length. All of these we are going to mention and we need to prove the result. Okay, so let us see. AP equal to AS, I am calling this like equation 1, and the next one will be BP equal to BQ, that I am calling like equation 2, and CR equal to CQ, that I am calling like equation 3, and dr equal to ds, I am calling this like equation 4. Now we are going to add all the 4 equations. 1 plus 2 plus 3 plus 4 implies, adding means we need to add all the LHS separately and add all the RHS separately. Let's see what happens. AP plus BP plus CR plus DR. This is the sum of all the LHS values. That side we have AS plus BQ plus CQ plus DS. Right? Now let us group the values together. Yeah, that implies AP plus BP. I am grouping these two together, and CR plus DR. I am grouping these two together, and here the DS I am bringing to the second position. So AS plus DS and then BQ plus CQ I am grouping together. Okay, that implies, see the picture, AP plus BP is the total length of AB, isn't it? So we can replace this with AB, and CR plus DR is the total length of CD, right? So we can write it like CD. On the other side, AS plus DS is nothing but AD, and BQ plus CQ is nothing but BC. Okay, so one thing we have to remember is, given this is a parallelogram, so we know that ABCD is a parallelogram already. So the parallelogram is already having a basic quality. What do you mean by that? Suppose if I draw the parallelogram separately like this, okay, the opposite sides will be equal to each other. So that means AB and CD are always equal to each other, and AD and BC sides are always equal to each other. That point we can apply here. Okay, and let us see what happens if we do that. But ABCD is a parallelogram Therefore, opposite sides are equal to each other. That implies AB equal to CD and BC equal to AD. Right? Now, whatever we have found here in the last step, let us call this as fifth equation, because we are going to put the thing we have found now in this fifth equation. Okay, let us see what happens. Therefore, equation 5 implies AB plus CD equal to BC plus AD implies AB plus CD I can write like AB only. Correct? And next what I am going to do is, this BC I am keeping as it is. AD is also equal to BC only. So I am going to replace that also with the BC. So this implies AB plus AB is 2 times AB and BC plus BC is 2 times BC. That implies AB equal to BC by dividing by a 2 on both sides. Right? 2 will cancel. So AB equal to BC. Now look at the parallelogram picture we have drawn here. AB side is this one and BC side is this one. They are the adjacent sides of the parallelogram. Yeah, they are not supposed to be equal to each other, but when they are equal to each other, that means AB and BC are equal, AB and CD are already equal. So and BC and AD are already equal, that will imply that AB, BC, CD, AD all will be of the same length, isn't it? That means that parallelogram is specially a rhombus, because a rhombus only has all the four sides equal to each other, right? So that is what the conclusion we are going to write now. AB equal to CD equal to BC, BC and AD are equal. So all the four sides will become equal to each other. Therefore, ABCD is a rhombus. That is what we need to prove, right? And we are done with the proof. Now let us move on to the next sum. The next option of this sum. Prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact at the center. Okay, let us try to understand what they are saying. If I draw two tangents from external point of a circle, okay, the angle which the two tangents create at the external point, I mean AP is a tangent and BP is another tangent which are drawn from the external point P. So the angle between AP and BP tangents is nothing but APB angle. Okay, that should be supplementary to the angle which is subtended at the point O. Right? That is what we need to prove. This is one famous theorem, right? So we have to prove it. Let us see how to do that. So this figure we have to draw without fail, and we need to explain something about the figure when the figure was drawn by us. Okay, so let us explain something. Let P be the external point and PA, PB be the tangents drawn from P to the circle with the center O. Okay, so now we need to prove this. One thing we already know is the angle between the tangent and the radius at the point of contact will be 90 degree. So what do you mean by that? Let us see. This is the tangent PA and this is the radius OA. So the angle between OA and PA will be 90 degrees. So this OAP angle will be 90 degree. The same way PB is a tangent and OB is the radius. So the angle between OB and PB, which is OBP, that is 90 degree. So those we already know by the theorem, and we always have to mention the theorem which we are using here without fail. So let us see how to prove that. We know that angle between the tangent and radius at the point of contact is 90 degree. That implies angle OAP equal to 90 degree as well as angle OBP equal to 90 degree. Okay. Now we are going to consider a quadrilateral OBPA. Okay. So let us draw that separately here. So this is the quadrilateral OAPB. Here we have a 90 degree. Here also we have a 90 degree. Okay. And we know by angle sum property of a quadrilateral, sum of all the angles is 360 degree, right? That we are going to use here. So in quadrilateral OAPB, by angle sum property, sum of the angles equal to 360 degree. Okay, let us write them. Angle APB plus angle OAP plus angle OBP plus angle AOB equal to 360 degree. Okay, and that implies angle APB we don't know yet, so let us keep it as it is. Angle OAP we already know, which is 90 degree, and angle OBP also we know, which is also 90 degree. Angle AOB we don't know now, but their total is 360 degree, right? So that implies angle APB plus angle AOB, and 90 plus 90 is 180. The other side we have 360. Now let us take this 180 to the other side. We will have angle APB plus angle AOB equal to 360 minus 180, that is again 180 degree. What do you mean by that? Sum of APB and AOB angles is equal to 180 degree. What do you mean by that? When the angles add up to 180 degree, they are called as supplementary angles, right? So that implies angle APB and AOB are supplementary angles. That is what we need to prove here. Okay, that's the end of the sum. Let us move on to the next. Sum 27 has two choices. The first one is prove that 1 plus 1 by tan square theta multiplied by 1 plus 1 by cot square theta is equal to 1 by sin square theta minus sin power 4 theta. When we need to prove something, okay, we need to start the proof from the most complicated side. Okay, so the LHS is the most complicated side, so we need to start from there. So let us see how we can prove this. LHS equal to 1 plus 1 by tan square theta multiplied by 1 plus 1 by cot square theta. Okay, and we know one thing here. 1 by tan theta is cot theta and 1 by cot theta is tan theta, right? And 1 by tan theta's whole square will be cot square theta, right? Respectively, we have to write it. So this will be 1 plus 1 by tan theta's whole square is there. That can be written like cot square theta. And the second value will also be 1 plus tan square theta. Okay. Now we have two identities that we are going to use here. What are they? 1 plus cot square theta equal to cosecant square theta, and 1 plus tan square theta equal to secant square theta. So these are the identities we are going to apply here. So the first bracket's value is cosecant square theta into the second bracket's value is secant square theta. Okay, and look at our answer side, the RHS side. There is no cosecant and secant coming. So we can plan our action according to this. Since everything is given in terms of sine, first let us write their values in terms of sine and cos, and later we will simplify that. So this will be cosecant is the reciprocal of sine, right? So cosecant theta is 1 by sine theta, and secant theta is 1 by cos theta, isn't it? That we can put here 1 by sine theta square into 1 by cos theta square, and 1 by sine theta whole square will be 1 by sine square theta, because 1's square is 1 only. So 1 by cos square theta is the next value. But look at the RHS again. There is no cos also, right? Cos is also not there. So we need to convert cos in terms of sine again. That we can easily do. We know that cos square theta plus sine square theta equal to 1 by the identities. So cos square theta can be written like 1 minus sine square theta. So let us implement this idea and let's see what happens. So that will be 1 by sine square theta into that 1 by cos square theta, we are now writing like 1 minus sine square theta. This is a product only, right? So we can just like that multiply both the numerators and denominators. So 1 into 1 is 1, and that product of the denominators is sine square theta into 1 minus sine square theta. Okay, now we can apply distributive property for the product in the denominator, and we can write it like sine square theta into 1 is sine square theta minus sine square into sine square is sine power 4 theta. That is the supposed to be RHS. So we got the answer correctly, and that's the proof. Okay, so hence proved. Let us go to the next sum. The next choice of the same sum is prove that root of cosecant theta minus 1 divided by cosecant theta plus 1 plus root of cosecant theta plus 1 by cosecant theta minus 1 equal to 2 secant theta. And as I always say, let us start from the most complicated side. So the LHS is the most complicated thing. So we have to start from the LHS only. So let us take the LHS and write it. Root of cosecant theta minus 1 by cosecant theta plus 1 plus root of cosecant theta plus 1 divided by cosecant theta minus 1. We need to separate out the root for the numerator and denominator. Otherwise, we won't be able to take LCM and simplify this, right? So let us do that first. This can be written like root of cosecant theta minus 1 divided by root of cosecant theta plus 1. The same way, the next also we can write like root of cosecant theta plus 1 divided by root of cosecant theta minus 1. How are we able to write this? Because root of a by b can be written like root of a by root of b for any a and b, right? So that's why we are writing like this. Now we have two fractions. So the only way to combine them is taking LCM. So we are going to do the same. The LCM for the denominator will be root of cosecant theta plus 1 multiplied by root of cosecant theta minus 1. So we have to multiply the respective numerators with the non-available factor, right? So that means the numerator of the first fraction is cosecant theta minus 1, and the non-available factor for that denominator is cosecant theta minus 1 in a root. That is what we have to multiply this numerator with. So this is a product here separately. And for the next thing, root of cosecant theta plus 1 is the numerator, and the missing factor is also the same, root of cosecant theta plus 1, right? So let us write it. So this is what we are having. Okay. Now again we know that root a into root b can be written like root of ab. So we can combine them inside the same root, or we can break them into separate roots, however we wish there, right? So in the first bracket, product of both of them can be combined inside the same square root, which can be cosecant theta minus 1. Okay. And then the same way, the next one also we can write cosecant theta plus 1 into cosecant theta plus 1, and the denominator also we are going to apply the same concept. So that also we will write it like cosecant theta plus 1 multiplied by cosecant theta minus 1 inside the same root. Okay. Now look at the values inside the first square root. Cosecant theta minus 1 and cosecant theta minus 1 both are the same item, right? Maybe let us treat it like a into a. So that is nothing but a square, right? And the same way here in the second root also, cosecant theta plus 1 and cosecant theta plus 1 are the same item multiplied by itself. That means a into a square, some same thing. And in the denominator we have a plus b into a minus b pattern. So that we have to apply the identity and simplify that. Okay. So let us apply all our ideas. Okay. Let's see. So that will be equal to root of cosecant theta minus 1 whole square plus root of cosecant theta plus 1 whole square, everything divided by root of cosecant square theta minus 1 square. So we have applied a plus b into a minus b equal to a square minus b square identity. Okay, now let us simplify further. Square and square root will always cancel each other, right? So the first value cosecant theta minus 1 will get released from the square root. The same way the next value also cosecant theta plus 1 also will get released from the square root, and in the denominator we have root of cosecant square theta minus 1 because 1 square is 1. And one thing we have to understand here is 1 plus cot square theta equal to cosecant square theta from the identities. If this 1 goes to the other side, what will happen? Cot square theta equal to cosecant square theta minus 1. Isn't it the same inside the square root in the denominator? So we can replace that with the cot square theta. So let us see. Now I am going to remove the brackets in the numerator. So we have to add them. Cosecant theta minus 1 plus cosecant theta plus 1 divided by root of cot square theta. Okay, and look in the numerator, minus 1 and plus 1 are cancelled. Cosecant theta plus cosecant theta will be 2 times cosecant theta, and root of cot square will be just a cot theta because square and square root will always cancel each other, right? Let's continue further. We can write it like 2 cosecant theta into 1 by cot theta. Okay. Why we are doing all this? Because look at the RHS of the proof. We have to have 2 secant theta there. Okay. So we need to convert them in terms of sine and cos, then only we will get some idea, right? So this will be 2 into cosecant is 1 by sine theta, and 1 by cot is nothing but a tan theta. Okay, and again we can write tan theta also in terms of sine and cos, which is sine theta by cos theta. Now this sine theta in the numerator and denominator will cancel. So we get 2 into 1 by cos theta finally, and 1 by cos theta is secant theta, of course. So we get 2 times secant theta. That is the RHS we are supposed to get. So we have proved the result. Okay, let us move on to the next sum. Sum 28. If the midpoint of the line segment joining the points A 3, 4 and B k, 6 is P of x, y and x plus y minus 10 equal to 0, then find the value of k. Okay, let us understand the given thing. There is a line segment AB whose midpoint is the point P. Okay, and there is a missing entry at the vertex B given. We need to find out that missing entry k. Okay, and one hint was given. Whatever is this x, y, the midpoint P, will satisfy this equation. So that means there is a line x plus y minus 10 equal to 0, and this P of x, y lies on that point also. Okay, so if you want to understand that, we can think about this. There is a line x plus y minus 10 which passes through the point P. The point x, y will satisfy the equation of the line. That aspect we are going to use after finding the midpoint. Okay, so let's see how to do this. We know that midpoint of A x1 y1 and B x2 y2 is x1 plus x2 by 2 comma y1 plus y2 by 2, right? This is the formula for finding the midpoints. So that implies P of x, y is equal to, if I call A as x1, y1 and B as x2, y2, then this will be 3 plus k by 2, 4 plus 6 by 2, isn't it? So this is our midpoint expected. Okay, now what do you mean by one ordered pair equal to another ordered pair? When will this happen? When the corresponding entries are equal to each other. I mean the first entry and the other first entry both should be equal to each other, vice versa, right? So that implies x is supposed to be equal to 3 plus k by 2 and y is supposed to be equal to 4 plus 6 by 2. Since there is no variable in the value of y, we can easily find the value of y. So this is equal to 10 by 2, which is 5. So y's value we already got to know. Therefore, point P is 3 plus k by 2, 5. So x's value is 3 plus k by 2, y's value is 5. Since P is lying on the line, P has to satisfy the line's equation. That we are going to do now. Since P 3 plus k by 2, 5 lies on the line x plus y minus 10 equal to 0, we should have replacing x with the x value of the point P, which is 3 plus k by 2, and replacing y with the y value of the point P, which is 5 minus 10, should be equal to 0. Okay, now if we solve this equation, we will get the value of k. Okay, so let us see. 3 plus k divided by 2 plus 5 minus 10 will be minus 5 equal to 0. if we take this minus 5 to the other side, we will get 3 plus k by 2 equal to plus 5. And if we do cross multiplication, we will get 3 plus k equal to 10. That implies k equal to 10 minus 3, which is 7. Okay, so that is the value they are asking us. Yeah, so the sum is over. Let us move on to the next sum. Sum 29. The length of the hour hand of a clock is 10 centimeter. Find the area of the minor sector swept by the hour hand of the clock between 5 am to 8 am. Also find the area of the major sector. Okay, so let us try to understand the given thing. Suppose if this is the hour hand of the clock, its length is given to be 10 centimeter. Okay, now see, we are observing the hour hand's position, first position at 5 am. Okay, and once it reaches 8 am, yeah, this position, we will notice that there is a sector, right? There is a sector formed between these two initial and final positions, right? So that sector's area we need to find out. That is a minor sector, obviously. Why? Because that angle is always less than 180 only. By seeing itself we can tell that, right? So this angle is less than 180, so this is a minor sector. So the aqua blue shaded region is a minor sector whose area we need to find out. And they are asking the major sector's area also. What do you mean by major sector? So leaving this blue shaded region, the rest of the region will be a sector, another sector. That is obviously a major sector because the central angle at that other part will be a reflex angle. So that is a major sector. Okay, so these two areas we have to find out. Okay, so let's see how we can do that. See, in order to find out the area of a sector, we know the formula, right? We know that area of a sector equal to pi r square theta divided by 360 degree. So if we know that angle, then only we can be able to find this area, right? So what is that angle? How we can find it out? So for that we have to understand something. So we know that if the hour hand is starting from 12 and it is making one full revolution and comes back again at the point 12, it would have swept one full circle. Okay, so that angle at the center will be 360 degrees. So now the time taken when the hour hand starts at 12 and comes back again to 12, by the time it would have taken 12 hours, right? So for 12 hours duration, the angle made at the center equal to 360 degree. So for 3 hours duration, how do you know that there is a 3-hour duration? From 5 o'clock to 8 o'clock, both in the morning. So for 3 hours duration, what will be the angle made at the center? That we need to find out. Okay, how can we do that? So for 12 hours, angle made is 360 degree. So for 3 hours, what is the angle made? So this can be done by unitary method, right? That will be found by multiplying 3 and 360 dividing by a 12, right? When we solve this, we will have 90 degree. Yeah, so this angle is a right angle, right? So this angle is a 90 degree. Now we need to use that theta here, and of course r is 10 centimeter. We can easily find the area of the minor sector. Okay, let us do that. This angle we have to write. Okay, central angle subtended by hover hand between 5 a.m. and 8 a.m. equal to 3 into 360 by 12, which is equal to 90 degree. Okay, therefore area of minor sector equal to 22 by 7 into r square will be 10 into 10, 10 square. Theta will be 90 degree divided by 360. This 90 and 360 we can divide 94 times 360, right? And 2 times, 2 5 times, again 2 1 time, 2 5 times, like that. So we have 22 into 5 into 5, 25 divided by 7. There is nothing in the denominator. So this 7 comes to the denominator, right? So when we multiply them, we will have 550 by 7 centimeter square, right? Centimeter square. Or we can convert this as a decimal also, and that will be 78.57 centimeter square approximately. Okay, now we are not yet done. We need to find the major sectors area also. We have a shortcut for this. Okay, if we find the area of the full circle, okay, and if we subtract the aqua blue shaded regions area from that circle's area, then this purple shaded regions area will be obtained. That is the area of the major sector, right? So no need to do the reflex angle and then apply the formula and do it again. There is the shortcut we can use. So let us see how we can do that. Let us find the area of the circle before that. Area of the circle is pi r square, which is 22 by 7 into r is 10, right? So 10 into 10. This will be 22 into 100, which is 2200 divided by 7. Okay, let us keep it as it is right now. Now let us find the area of the major segment. So area of the major segment equal to area of the circle minus area of the minor segment. Right? So that is equal to area of the circle is 2200 by 7, and for the minor segments area, let us take the fractional version of the area. Let us not take the decimal version. 550 by 7 we can put now. Okay, now we can easily take LCM. That's why I have taken that. So 7 is the LCM. So we have to subtract the numerators, and their difference will be 1650, right? So 1650 by 7, or we can convert it again as a decimal, whose answer is 235.71 centimeter square approximately. Okay, so both the areas we have found, and that's the end of the sum. Let us move on to the next. Sum 30. Prove that root 3 is an irrational number. So whenever we need to prove some number as irrational, we always use the method of contradiction for proving it, right? So what do you mean by method of contradiction? We always assume the other way. Other way means instead of root 3 being irrational number, we will assume now that root 3 is a rational number. Since it is wrong, obviously, that will end up having a contradiction finally. So we will accept our fault that this is wrong, my assumption is wrong, so root 3 is not supposed to be a rational number, etc. Okay, so let us see how to prove it. let us assume that root 3 is a rational number. Okay, we know the definition of a rational number. Whenever we are having a rational number that can be represented in the form of p by q, where p and q are integers and the denominator is not supposed to be 0, and both p and q's are not going to have any common factors, right? That is the definition of any rational number. So this also we can write the same way. That implies root 3 equal to some p by q, where p and q are integers, q is not equal to 0, and p and q are coprimes, right? So now let us see what will happen. Now since I have taken root 3 equal to p by q, I am going to cross multiply this q to the other side. Okay, so root 3 into q equal to p. Now we are going to square both the sides. So on squaring both the sides, we will get root 3 square into q square equal to p square. So that implies 3q square equal to p square. Correct? So that is p square equal to 3q square. I have swapped both the sides. So when I am saying that p square is a product of 3 and another number, it should be a multiple of 3, right? So that implies p square is a multiple of 3. So it should be divisible by 3, obviously, right? So it will be divisible by 3. Okay, and we learnt in a theorem that whenever square of a divides a number, then a should also divide the number, right? I mean, when p square is divisible by 3, p is also divisible by 3. Otherwise, this is not possible, right? So, that implies p is divisible by 3. So, when we say that a number is divisible by 3, when it is a multiple of 3, right? So, that implies p is a multiple of 3. So, any multiple of 3 can be written like 3 into some number. So, p can be written like 3 times a, where a is an integer, some integer. Okay. So, p equal to 3a, we are going to apply in this equation, which I am naming as 1. Okay. So, therefore, 1 implies p square equal to 3q square implies p's value is 3a now, right? Remember? So, 3a whole square equal to 3q square, isn't it? I can square both of the items inside the square, right? So, that will be 9a square equal to 3q square. Since I have a multiple of 3 on both sides, I can divide by 3 throughout. So, I will get 3a square equal to q square. Swapping the sides, I have q square equal to 3a square. What I mean here, q square equal to 3 into some number. That means q square is a multiple of 3, right? So that implies q square is a multiple of 3. So it is divisible by 3. So if q square is divisible by 3, then q is also divisible by 3. That implies q is a multiple of 3, right? So that implies q can be written 3 into some number, right? So I am writing q equal to 3 into b, where b is an integer. Okay, now look at p's value. P's value is 3 into a and q's value is 3 into b. What do you mean by that? Yeah, 3 is a common factor in both their factorizations, right? Is it allowed for us? See what we have assumed. P and Q are co-primes. What do you mean by that? They don't have any common factors other than 1, right? That is the meaning of co-prime numbers, right? But we are getting 3 is a common factor for both P and Q, which is not supposed to be. So we are getting a contradiction to our own assumption, right? What is our assumption? P and Q are co-primes, right? So because of this contradiction, what is our final conclusion here? Therefore, our assumption is wrong. What was our assumption? Root 3 is a rational number is our assumption, right? Now it is wrong. Therefore, root 3 is not a rational number. If the number is not a rational number, then it is an irrational number only, right? Therefore, root 3 is irrational. That is the proof. Okay, let us move on. Sum number 31. A sum of rupees 2000 is invested at 7% per annum simple interest. Calculate the interest at the end of first, second and third year. Do these interests form an AP? If so, find the interest at the end of the 27th year. Okay, so now let us understand the thing. We are investing rupees 2000. So that is our principal. Okay, and the rate percent is given as 7% per annum. Okay, this is simple interest. Okay, so for 1 year we are going to find out. So simple interest at the end of first year. So the time period is basically 1, right? So that will be P into R into time divided by 100. That is equal to 2000 into 7 into time is 1 now divided by 100. Now we can cut 2 zeros here. So the answer for this is 140 rupees. Correct? The same way we have to calculate simple interest at the end of second year. Let us do that. So in this case we need to find the simple interest for 2 years, right? Principal and the rate percent will be the same, right? So it will be P into R into time divided by 100. Time will be different now. So this is 2000 into 7 into 2 divided by 100. We can cut 2 zeros here and this will be 280 rupees. Okay, and let us do the third year thing also. Simple interest at the end of third year. Again P into R into time by 100. But time is 3 years now. So this will become 2000 into 7 into 3 divided by 100. Cancelling these two zeros, we have 420 rupees. Okay, so we have done one part of the sum. Now the next question they are asking is, do these interest form an AP? Let us observe the values: 140 rupees, 280 rupees and 420 rupees. Are they having the same common difference every time? See, 140 plus 140 is 280. 280 plus 140 is 420. So, they are having the same difference between each other. So, are we able to say it is forming an AP? Of course. Yeah, it is forming an AP. So, provided it is an AP, what can be the interest at the end of 27th year? Suppose if we are maintaining the investment for 27 years, at the end of 27 years, what is the simple interest you are expecting? Yeah, That we can easily find by finding the 27th term of the AP. Yeah. So let us answer one by one. Clearly, the values 140, 280, 420 form an AP with the first term 140 and common difference is also 140. Correct? Common difference 140. Therefore, 140, 280, 420, etc. is an AP. So, now we are going to find the 27th term of this AP. Clearly, interest at the end of the 27th year will be the 27th term of the AP. We can easily find the term 27 by applying the formula for this. We know that nth term equal to a plus n minus 1 into d, where a and d are the first term and the common difference, right? So, that implies term 27 equal to first term is 140 and the common difference is also 140. So, 140 plus 27 minus 1 into 140. So, this is 140 plus 27 minus 1 is 26 into 140. That will be 140 plus the product of 26 and 140 is 3640. And adding these two, we get 3780 rupees. So, the interest at the end of 27th year will be 3780 rupees. That's the end of the sum. Let us solve section D, long answer type questions carrying 5 marks each. Sum 32 has two choices. The first one is two ships are sailing in the sea on either side of a lighthouse. The angles of depression to the two ships as observed from the top of the lighthouse are 60 degree and 45 degree respectively. If the distance between the ships is 100 into 1 plus root 3 by root 3 meters, then find the height of the lighthouse. Okay, so let us try to understand the sum. So this is the lighthouse. This is our ship number 1 and this is our ship number 2. The person is standing here and the person is observing both the ships from there. So from here to here and here to here, two angles of depressions will be formed. Okay, and those are given here. So one thing we have to understand is when we are looking at something which is far away from us, we don't need to stretch our eyes too low, right? We can easily observe that item without any struggle. So we will lower our eye only a little bit. Okay. So the angle of depression will be less when we look at a farther item. Okay. But when the thing we are looking at is closer to us and we are at a huge tower or lighthouse or like something, our eyes will stretch a lot to look at that item, right? So that will be having a big angle of depression. So basically here this ship is close to the lighthouse, whereas this ship is farther from the lighthouse. Did you observe that? Because of that, the ship which is closer to the lighthouse will have more angle of depression than the ship which is farther. Okay, so considering all of these, we have to attend this sum. See, I have drawn this picture with a stick diagram. AB is the lighthouse we have taken, and S1 is the position of the ship number 1 which is close to the lighthouse, and S2 is the position of the ship number 2 which is little farther than the ship 1, and we need to draw the eye level of the observer who is standing at the point B now. So that red line is that one, and these two angles I have marked are the angles of depression. Now we need to mark them. Okay, as I told you, the close by ship will have bigger angle of depression, and the far by ship will have smaller angle of depression. And we know that this red line and this line segment joining S1 and S2 will be parallel to each other, right? So because of that, this angle will also be 60 degree, because these two angles are alternate interior angles. They are always equal to each other. The same way, this angle will be 45 degree, because these two angles are alternate interior angles. They are also equal to each other. And of course, any standing object will make 90 degree with the ground. So this will be 90 and this also will be 90. So this is the basic understanding of the scenario. And one more thing given is the distance between S1 and S2 is totally 100 into 1 plus root 3 by root 3 meter. We can use this information given. Distance between S1 and S2 will be S1A plus AS2. So I will find S1A and AS2 from the two triangles we have taken separately, and we will add both of them together and we will equate it to 100 into 1 plus root 3 by root 3. So that is the idea here. Let us execute it. So for our understanding, I am drawing the smaller picture of the triangles which we are going to take. So this is 60 degree. This is our ABS1 triangle. Okay, and this is our ABS2 triangle. Here it is 45 degree. In right triangle ABS1, see, I need the base S1A. Okay, and the perpendicular also we need the height of the lighthouse we need. Okay, so let us take the height of the lighthouse as h meters, and we will write it here. Okay, so let the height of the lighthouse be h meters. Okay, so now in right triangle ABS1, we need the base's length and the perpendicular's length as well. We are not bothered about the hypotenuse at all, right? So the base and the perpendicular are connected by tan of the angle 60 degree. Okay, so tan 60 degree equal to perpendicular divided by base, and for this triangle it is AB by S1A. Okay, but we know the value of tan 60, which is root 3, right? So root 3 equal to AB we have taken like h, remember? So h divided by S1A. So now let us cross multiply. Root 3 into S1A equal to h. I need the value of S1A. Okay, so I am writing S1A equal to h divided by root 3. Okay, let us reserve this for later purpose. Let us call this like equation 1. Now let's take the next triangle. So in right triangle ABS2, here also I am going to do tan of the angle only. Tan 45 degree equal to AB divided by AS2. Yeah, that will be h by AS2. Correct? Tan 45's value is 1, remember? So 1 equal to h by AS2. When we cross multiply, we get AS2 into 1, which is AS2 only. That is equal to H. Let us save this and call this equation 2. Okay. And what is given to you already? Given distance between the ships equal to 100 into 1 plus root 3 divided by root 3 meters. Distance between the ships is nothing but S1A plus S2 from the picture we have drawn, right? This is equal to 100 into 1 plus root 3 divided by 3 meters. What is our S1A? That is nothing but H root 3, H by root 3, and S2 is nothing but H, right? So this is equal to 100 into 1 plus root 3 divided by, this is root 3. How do you know that S1A and AS2's value? From equations 1 and 2, right? Okay. Now what we are going to do is, we are going to take root 3 as an LCM. So we will get H plus H into root 3 equal to 100 into 1 plus root 3 divided by root 3. Okay. And that implies H we can take common from the numerator also. So H into 1 plus root 3 divided by root 3 equal to 100 into 1 plus root 3 divided by root 3. Okay, so that implies H equal to, we can cross multiply this to the other side. So this is 100 into 1 plus root 3 divided by root 3. And when we send a fraction to the other side, it will get reciprocated, right? So root 3 goes up and 1 plus root 3 goes down. And after cancelling root 3 and this 1 plus root 3, we simply get 100 meters. Okay, so height of the lighthouse is nothing but 100 meters. Okay, so that is what they are asking, right? So we are done with the sum. Just to give a statement conclusion, because this is a word problem. Therefore, height of the lighthouse equal to 100 meters. Okay, that's the end of the sum. Let us move on to the next one. The other option of the same sum. It is given that the angles of depression of the top and bottom of an 8-meter tall building from the top of another multi-storied building are 30 degree and 45 degree respectively. Find the height of the multi-storied building and the distance between the two buildings. So we have a picture here, okay, to illustrate the idea. Okay, see, there is a building which is 8-meter tall. So this is our 8-meter tall building, and the other one is a very huge tall building which is a multi-storied one, and the person who is the observer is standing right here on the terrace of the multi-storied building, and the person is looking at the top of this small building as well as foot of the small building at the same time. Suppose if I call this point like C and this point like D, if the position of the observer I have marked as B and the foot of this building like A, the person who is standing at B is watching the points D and C both at the same time. So there will be two depression angles formed here also, like the previous sum. One thing we have to understand is, when the observer is looking at something which is higher in position, the angle of depression will be lesser compared to the other. Okay, so when the person looks at the point D, the depression angle will be smaller. When the person looks at the point C, the depression angle will be more than the previous angle. So come to this diagram, the stick diagram. AB and CD are the multi-storied building and the small building, and this is 8 meter. This one we don't know. Okay, and this B is the position of the observer. So we have drawn the eye level of the observer with the red dotted line, and the observer is looking at the point D with a depression angle 30 degree. Okay, and the point C with a depression angle 45 degree. Okay, and again we know that this BX line, ED line and AC line all are parallel to each other, because the eye level horizontal at the position of the observer will be the same level with the ground, right? They are parallel to each other. So these three lines are parallel to each other. So because of that, since this XBD angle is 30 degree, this BDE angle is also 30 degree, because they both are alternate interior angles. Same way, XBC angle is 45 degree. So BCA angle is also 45 degree. And one thing we have to understand is AE, CD both are parallel to each other. At the same time, ED and AC also parallel to each other. Because of that, ACDE will be a rectangle, right? Because there is a 90 degree here and here also. So this is a rectangle. So the opposite sides of the rectangle are always equal to each other. Since CD is 8 meter, AE is also 8 meter only, right? So these are the basic informations we can tell about the scenario, and rest of the things we have to find out here. So what are the things we have to find out? Distance between the two buildings, I mean the distance between the points A and C. Here I am calling it like x meters. Okay, since ACDE is a rectangle, DE is also x meters long only. Okay, and this BE I am calling like y. Okay, so now we have to find out the missing values like x and y. After finding them, the multi-storied building's height will be the sum of AE and BE, which is 8 plus y, that we can easily say, and the value of x is the distance between the two buildings, that also we can easily say. Okay, so let us go for the calculations, and for our convenience I am going to draw these two triangles we are going to consider. Okay, I'll tell about that also. The triangles which we are going to consider here will be ABC triangle and BED triangle. Okay, so I will draw them separately to understand them better, and we will apply the correct required trigonometric ratio and find out the values. So let us draw them. Okay, so I have drawn both the right triangles which we are going to take here. Okay, let us go one by one. In right triangle BED, I am going to apply tan only, because here also perpendicular and base are under discussion. So tan 30 degree equal to perpendicular is BE and the base is ED. So this is nothing but y and this is x. Tan 30's value is 1 by root 3. Okay, so 1 by root 3 equal to y by x. Okay, so when we cross multiply, we can get x equal to y into root 3. So this we are going to reserve for future use. We are calling this like equation 1. Okay, let us take the next triangle. In right triangle ABC, there also I am going to apply tan only. Tan 45 equal to perpendicular is AB and base is AC, and AB's value is 8 plus y, remember. AC is the same x. Tan 45's value is 1, right? So 1 equal to 8 plus y divided by x. Doing cross multiplication, we get x equal to 8 plus y. This we will save for our later use, calling this like equation 2. Okay, now look at our equation 1 and 2. Both of them are having x in the LHS. So what do you mean by that? Both the LHS are equal. So both their RHS will be equal to each other. So we can equate them from equations 1 and 2. Y into root 3 equal to 8 plus y. All the y values we would like to combine in one side of the equation. So let us take this y also to the other side. So y into root 3 minus y equal to 8. We can take y common from both of them. So we get root 3 minus 1 equal to 8, right? Let us take root 3 minus 1 to the other side. So it will go to the other side denominator, right? So we will get 8 by root 3 minus 1. But we have to rationalize this, right? So when we rationalize, we have to multiply by root 3 plus 1, both in the numerator and denominator. So we will get 8 into root 3 plus 1 divided by root 3 minus 1 into root 3 plus 1. That will be 8 into root 3 plus 1 divided by root 3 whole square minus 1 square, because this is of the form a minus b into a plus b. So we can apply the identity here and write this way. This will become 8 into root 3 plus 1 divided by root 3 square is 3 minus 1 square is 1. So this will be 8 into root 3 plus 1 divided by 3 minus 1 is 2. We can cut this. So we are getting 4 into root 3 plus 1 as the answer for our y value. Okay, and if we want, we can put the value of root 3 also, or we can leave this way also. Let us put the value of root 3. 4 into 1.732 plus 1, that is equal to 4 into 2.732. Okay, and that will be equal to 10.928 meters, obviously. Okay, so y's value is here. Now we need to find out the value of x. We can use the equation 2 to find the value of x, which is much simpler. Okay, y equal to 10.928 in equation 2 implies x equal to 8 plus 10.928. That will be 18.928 meter. So x is nothing but the distance between the buildings, remember? So that we have found. Now we need to find out the height of the multi-storied building, okay, which is 8 plus y. So what do you mean here? Height is 8 plus y and distance between the buildings is x. So both of them are equal to each other from equation 2. So height of the multi-storied building as well as distance between the buildings is the same. Okay, so let us write the conclusion. Okay, so that is the end of the sum. Let us move on. Sum 33 has two choices. The first one is the sum of the areas of two squares is 52 centimeter square and the difference of their perimeters is 8 centimeter. Okay, find the lengths of the sides of the two squares. I have drawn two squares. Okay, see, they are not saying both the squares are of the same size, right? So one square is smaller in size, another one is bigger. Okay, that's how we have taken, and we are going to take the side of the bigger square like x centimeter and the side of the smaller square like y centimeter. Okay, sum of the areas is given as 52 centimeter square. We know the area of the square, right? So area of the square PQRS, which is the bigger one, is x square centimeter square, and the area of the smaller square will be y square, right? So when we add both of them, we should get 52 as the answer. That is the first condition. But before doing everything, we have to assign the variables properly. So let us do that. So we are mentioning that let PQRS and ABCD be the required squares whose sides are x centimeter and y centimeter respectively, and let x is bigger than y. That's how we have taken them, right? So why we are mentioning this? Because when we are doing the difference of the perimeters, of course the larger square will have a larger perimeter. So just to get the clarity, we are mentioning it already in the beginning of the sum. Okay, so let us continue. According to the given information, sum of the areas of both squares equal to 52 centimeter square. That implies x square plus y square equal to 52. Okay, this is our equation number 1. Now let us apply the next idea. Difference of their perimeters, right? That we have to do. So given the difference between the perimeters of both the squares is 8 centimeter. And what about the perimeter of a square? It is sum of all the sides, right? It will be 4x for the first square, bigger one, and 4y for the smaller one, right? Of course, the bigger one's perimeter is bigger. So 4x minus 4y will be equal to 8. Correct? And if we divide by a 4 throughout, we get x minus y equal to 2. Let us call this equation 2. Okay, see, we have to solve two equations here. One is a degree 2 equation and the other one is a degree 1 equation. When we have something like that, the elimination method won't be helpful, right? We are not able to use the elimination method because elimination method supports us when the variables are having the same degree. So we are not going to use that. We are going to use the substitution method. Okay, what is the substitution we are going to do here? We are going to take x value from the second equation and we are going to apply that in the first equation. Okay, let us do that. This implies, we better not name it now. Okay, this implies x equal to 2 plus y. Let us name this as 2. Okay, so now we are going to use this x value in the first equation. Using equation 2 in equation 1, we have x square plus y square equal to 52 and x equal to 2 plus y implies 2 plus y whole power 2 plus y square equal to 52. 2 square plus y square plus 2 into y. Right, that is the expansion, plus y square equal to 52. That implies 4 plus y square plus 4y. No need for the brackets, right? We can just add them. So this will give us y square plus y square are the like terms. We can add them together. 2y square plus 4y plus 4 equal to 52. And let us bring this 52 to the left side. We get 2y square plus 4y plus 4 minus 52 equal to 0. That implies 2y square plus 4y minus 48 equal to 0. Since 2 is the number available in all the terms, we can divide entirely by a 2 to reduce this equation a bit. So dividing by 2 will give us y square plus 2y minus 24 equal to 0, isn't it? Now we have to find the value of y. Okay, that can be done by using the factorization method. So let us do the splitting the middle term process. So the product of the factors is minus 24 here and sum of the factors is plus 2 here. Plus 6 and minus 4 are the expected factors. So let us split the middle term now. Y square plus 6y minus 4y minus 24 equal to 0. Right? That implies y can be taken common from the first two and 4 can be taken common from the next two. So what will happen? Let us see. Y into y plus 6 minus 4 into y plus 6 equal to 0. And these two are common. We can take them common. So combining the remaining things in another bracket, we get y minus 4. So product of two items is equal to 0 means any one of them is equal to 0. That implies either y plus 6 is 0 or y minus 4 is 0. Y plus 6 equal to 0 is possible when y equal to minus 6, or y minus 4 equal to 0 means y equal to 4. But think about something. Y is the side of a square, which can never become negative, right? Y we are going to take as 4. Okay, so the smaller square's side length is 4 centimeter. Okay, and what about the x value? We can easily find out x value. X equal to 2 plus y, which is equal to 2 plus 4, which is 6. So finding the length of the sides is the question here. Therefore, so that is the final answer. Let us move on to the next option. The time taken by a person to travel an upward distance of 150 km was 2.5 hours, more than the time taken in the downward return journey. Okay, if he returned at a speed of 10 km per hour more than the speed while going up, find the speeds in each direction. Okay, so let us try to understand. I am splitting this scenario into two now. One is the upward journey, the other is the downward journey. So the upward journey's distance is given, which is 150 kilometers, and the upward time taken is not directly given, but they are saying the upward time taken is 2.5 hours more than the time taken in the downward journey. So if we take the downward journey time taken as t1, this guy will be t1 plus 2.5 hours. Okay, so let us write it now. Time taken equal to t1 plus, this is the time taken t2 upward journey, t1 plus 2.5 hours. Okay, and what about the speed? What they have given here is, in the downward journey they are saying returned at a speed of 10 km per hour more than the speed while upward journey. So if we take the speed in the upward journey like x kilometers per hour, okay, let us see what will happen in the downward journey. Now what about the distance? See, the person has gone 150 kilometer and coming back the same, right? So the distance will be the same, 150 kilometers. And the time taken we are calling like time 1, t1. I have already told you. That is not known to us actually. Okay, that is not known to us. So let us keep it as it is. Time taken. We don't know that. And what about the speed? Speed we know. Speed is 10 km per hour more than the previous speed. So it will be x plus 10 kilometers per hour. Right? So this is the scenario we have. We have to create one equation and solve it. Okay. So how we can create the equation? What is the hold here? Yeah. The hold is difference between the time taken is 2.5 hours. Okay, so which time is a bigger quantity? Since the speed in upward journey was less, that time taken is more obviously. Time 2 minus time 1 equal to 2.5 hours. Okay, so we have to find out both the time takens according to the scenario. Let us see how to do that. Okay, we know that time taken is equal to distance by speed, isn't it? because speed equal to distance by time taken. So we can use this formula for finding the time taken in both the scenarios. Okay, so time taken in upward journey is equal to 150 divided by x hours, correct? But we have to mention all the values what we are going to take here. So let x kilometers per hour be the speed of the person during the upward journey. Okay, so we have time taken in upward journey like this, and we need to write the time taken in the downward journey also. Distance is 150 only, but the speed is x plus 10. So x plus 10 we have to put here. This is also is going to be in hours only. And we know that upward journey timing is more, right? T2 is more. So T2 minus T1 equal to 2.5 hours. Okay, so according to the given condition, two and a half hours. So here I am mentioning that this is time 2, this is time 1. Okay, 2.5 hours we can't use, so we have to convert it as a improper fraction. So let us continue. T2 is 150 by x and T1 is 150 by x plus 10 equal to 2.5 as an improper fraction will be 5 by 2, right? So we need to solve this quadratic equation, right? We are going to get a quadratic equation here. Let's see how. Taking x into x plus 10 as a LCM. Here we have 150 into x plus 10 minus 150 into x is 150x. This side we have 5 by 2. That implies 150x plus 1500 minus 150x by x square plus 10x. I have multiplied x and x plus 10 equal to 5 by 2. That implies now 150x will cancel in the numerator. 1500 divided by x square plus 10x equal to 5 divided by 2. Cross multiplying we get 2 into 1500 equal to 5 into x square plus 10x. That implies 3000 equal to 5x square plus 50x. Okay, let us swap the sides. 5x square plus 50x equal to 3000. Taking this 3000 to the left side, we have 5x square plus 50x minus 3000 equal to 0. Now we can divide entirely by a 5, right? So dividing by 5 throughout, we get x square plus 50 by 5 is 10 and 3000 by 5 will be 600, right? So we get x square plus 10x minus 600 equal to 0. This equation we have to solve now. So we can apply any method, okay? See, we can do the splitting the middle term process also, or we can apply the quadratic formula also, whichever is convenient. Okay, so let us do the splitting the middle term process. Product of the factors is supposed to be minus 600 and sum of the factors is supposed to be plus 10. And what are the factors we are going to consider here is plus 30 and minus 20, whose product is minus 600, whose sum is plus 10. So let us apply our factors found here. X square plus 30x minus 20x minus 600 equal to 0. That implies combining the first two terms, we can take x common. So we get x plus 30 in the brackets, and combining the third and fourth quantities, we can take minus 20 common. We will get x plus 30 in the brackets. And this x plus 30 is a common binomial. We can take it out common. And the next two items combined will be x minus 20. So this will x plus 30 equal to 0 or x minus 20 equal to 0. That implies x equal to minus 30 or x equal to plus 20. Remember what is our x here? X is the speed of the person. That can never be negative, right? Speed cannot be negative. So we are going with the next value, x equal to 20. Okay. So now we have to answer the question. See, find the speeds in each direction they are asking. So we need to tell them what is the upward travel speed and what is the downward travel speed. Equal to 20 kilometer per hour. That is what we have taken as x, right? And speed during downward travel is 10 kilometers more than the previous one. So 20 plus 10, 30 kilometers per hour. Okay, that is the conclusion. Let us move on to the next sum. Prove that a line drawn parallel to one side of a triangle to intersect the other two sides in distinct points divides the other two sides in the same ratio. Hence, in the figure given below, prove that AM by MB equal to AN by ND, where LM is parallel to CB and LN is parallel to CD. So this is what is given to us. So what we have to prove is this ratio. So let us try to prove it. Given LM parallel to CB and LN parallel to CD. And to prove is AM by MB equal to AN by ND. Okay, so we are going to prove it. For that, we need to draw the triangles separately. Let's see what are the triangles we are going to consider. Okay, so for our convenience, I have drawn the figure into two triangles like this. And we are going to use the concept of basic proportionality theorem in this proof. Okay, so what is the concept of basic proportionality theorem says? If I have a triangle, okay, and if I have taken 2 points from two sides of the triangle and I have connected a parallel line, okay, to the third side, then if this is our ABC triangle and this is our DE points, then AD divided by DB will be the same like AE divided by EC, right? That is our basic proportionality theorem's statement that we are going to use here. How we can take the help of BPT? Because LM and CB are parallel to each other. Remember, that is given to us. Same way, LN and CD are also parallel to each other. So that's how we are going to apply BPT here. So in triangle ABC, LM parallel to BC. Therefore, by basic proportionality theorem, what we can write is AM divided by MB equal to AL divided by LC, right? We are going to use this later. So we are saving it as our equation 1. Okay, now for the next triangle also, we are going to say AL by LC equal to AN by ND. Okay, let's do that. In triangle ADC, Ln parallel to CD. Therefore, by basic proportionality theorem, AN by ND equal to AL by LC. This I am going to call like our second equation. Now look at our first and second equations and let's see is there any similarity between them. Okay, see the RHS of equation 1 is AL by LC, and for equation 2 also we have the same RHS. So from 1 and 2 we can say both the RHS are equal. So their corresponding LHS are supposed to be equal to each other, and the LHS of equation 1 is AM by MB. So AM by MB should be equal to AN by ND, which is the LHS of equation 2, and that is the ratio they are asking us to prove. Okay, the sum is over, so hence proved. That's it. Okay, let us move on. Sum number 35. Find the mean and mode of the following frequency distribution. So they have given the class interval and the frequencies of each classes, and they did not mention any method to apply. So whether we need to apply the step deviation method or assumed mean method, nothing they have mentioned, right? So we can use whatever method we like. Okay, that's not a problem. First we need to do the means calculation. So let us do that. For that I am taking the class values in the first column and the frequency in the second column, and the mid value of the class intervals I am going to take in the third column, mid xi, and we can find out using the step deviation method because that is the easiest method among all the three methods. So we are going to find out ui equal to xi minus assumed mean divided by size of the class, right? Size of the class is 10 here, so that I am going to put here. That assumed mean we will decide later. Okay, so here we will find out fi into ui in the last column. So let us continue. The class intervals are given like 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. And the frequencies are 8, 7, 15, 20, 12, 8 and 10. So the middle values for each class intervals will be the midpoint or the average between the lower limit and the upper limit values. So the mid value xi for the first row will be 0 plus 10 by 2, which is 10 by 2, 5. For the next class it will be 15 and 25, 35, 45, 55 and 65, right? And the assumed mean will be the middlemost entry. We usually take the middlemost entry as the assumed mean. So I am taking this 35 as my assumed mean here. That 35 I am going to put here. Okay, so this is like xi minus 35 divided by 10. Okay, and we need to find out ui for each rows now. So for the first row, xi is 5, right? So first row's value will be 5 minus 35 by 10, right? That will be minus 30 by 10, which is minus 3. Okay, for the next row, it will be 15 minus 35 divided by 10, which will be minus 20 by 10, which is minus 2. And for the next row, it will be 25 minus 35 divided by 10, which is minus 10 by 10, minus 1. And for the next row, it is going to be 0 because 35 minus 35, 0. So 0 we will get. And for the next row, 45 minus 35 by 10 will be 10 by 10, 1. And for the next row, 55 minus 35 by 10 will be 20 by 10, 2. And for the next row, 65 minus 35 by 10 will be 30 by 10, 3. Okay, so we are ready with the UI values and frequencies also we have here FIs. Now we need to multiply FI and UI. So the product of second and fourth column values we have to find out and put it in the fifth column. So 8 into minus 3 will be minus 24. Okay, the same way 7 into minus 2 is minus 14. And 15 into minus 1 will be minus 15, and the next row's value is 0, and 12 into 1 will be 12, and 8 into 2 will be 16, and 10 into 3 will be 30. And we need to find the total for the frequency column and FIUI column, remember. So this total we need, second column total, and fifth column total also we need. Okay, let us add all the values in the second column. It will be 8 plus 7 plus 15 plus 20 plus 12 plus 8 plus 10 will be 80. Okay, and let us add all the FIUI values here. See, few of the values are negative here and few of the values are positive here, right? So sigma Fi Ui, we have to add the negative values separately and positive values separately. Okay, and this will give us minus 53 plus 58, whose total is 5. So this total is 5. Yeah, and now we are ready with the values. Let us find the mean value now. The formula for finding the mean value for the step deviation method will be A plus sigma Fi Ui divided by sigma Fi into H. Okay, and H value will be 10 because the difference between upper limit value and the lower limit value of every class interval will be 10 only, right? So now let us put the values here. A value will be 35. So this is 35. And FIUI total is 5. And FI total is 80. And H value is 10. Now we can try to cancel something in the curly brackets. So 10 and 80, 8 times we can cancel. So this will be 35 plus 5 by 8. And this will be 35 plus 5 by 8's value will be 0.625. Okay, so when we add both of them, we will get 35.625 as the value of mean. Okay, now we need to find out the mode of this distribution also. So let us try to do that. So for calculating the mode, I have taken the distributions table once again. Okay, for calculation of mode, we don't need any extra, right? Only 2 columns are enough. So what is the procedure? In the frequency column, we have to select the highest frequency, right? So what is the highest frequency we have? 20, right? So this row containing 20 is our model class, right? So we have to mention this as our model class. Okay, and we need the lower limit of the model class, which is 30, and we call it like L, right? And the frequency of the model class we will take like F1. Okay, and the frequency which is before the model class we will call it like F0, and the frequency which is after the model class we will call like F2, right? And obviously this class interval size will be same 10 only. So let us mark down the values we have noted. L equal to 30 and H is 10 and F1 is 20 and F0 equal to 15 and F2 equal to 12. And about the formula of the mode equal to L plus F1 minus F0 by 2F1 minus F0 minus F2 into H, right? So 30 plus F1 is 20 minus F0 is 15 divided by 2 times F1 will be 2 times 20, which is 40, minus F0 is again 15 and F2 is again 12 into H is 10. Okay, so let us simplify this further. 30 plus 20 minus 15 is 5. 40 minus 15 minus 12 will be 40 minus 27, right? And that will be 13, correct? Into 10 is there. And that can be written like 30 plus 50 by 13. Okay, that will be 30 plus 3.85, approximate value only. 50 by 13's value will be 3.85. So adding them together we get 33.85, approximate value only. Okay. Let us solve section E, case study based questions carrying 4 marks each. Sum number 36. A school is organizing a grand cultural event to show the talent of its students. To accommodate the guests, the school plans to rent chairs and tables from a local supplier. It finds that rent for each chair is rupee 50 and for each table is rupee 200. The school spends rupee 30,000 for renting the chairs and tables. Also, the total number of items rented are 300. If the school rents X chairs and Y tables, answer the following questions. So, this is a linear equation based case study. So, let us try to understand. So, for an event, the school organization is renting some chairs and tables. The total number of items, all items together is 300, and the rent for one chair is rupee 50 and rent for one table is rupee 200, and they are spending a total of 30,000 for this renting purpose. So we need to answer the following questions. Question number 1. Write down the pair of linear equations representing the given information. Okay, so we have to write a pair of linear equations, right? One, we can use the information they have given on the total items rented, okay? And another equation we can write based on the rent they are going to pay, okay? So for example, total items rented equal to 300. So they already have told us that X chairs and Y tables are rented, okay? So they themselves have decided the variables there. So that implies X plus Y equal to 300. That's our first equation. Okay, and let us see. For rent for one chair is rupee 50 and X chairs are rented. So X into 50 rupees they have to pay, right? So 50X rupees. Same way, Y tables are rented and the rent for one table is rupee 200. So for Y tables they have to pay 200 Y rupees, right? So the total money they have to pay is 50X plus 200 Y, right? And that money should be equal to 30,000 rupees, right? So that is the idea for the next equation. Let us see how to write it. Rent to be paid for X chairs is equal to rupee 50X and rent to be paid for Y tables, 200Y. Therefore, total rent equal to 50x plus 200y rupees. This should be equal to 30,000, right? That gives us the idea for the second equation. 50x plus 200y equal to 30,000. But we can reduce this equation. See, the coefficients are very big here, right? So we have to simplify them. Otherwise, we will have many difficulties when we are solving them. Okay, so each of these numbers are multiples of 50 only. So we can divide with the 50 throughout, right? So dividing by 50 throughout, x plus 54 times 200, right? So 4y equal to, here we will get 600, right? 600. This we are going to call like equation 2. That much is what they are asking here. So we are done with this part. Let us move on to the next one. Sum 2 has two choices. Number 1, find the number of chairs and number of tables rented by the school. So basically we have to solve the equations, otherwise we won't be able to tell that, right? So let us try to solve them. The first equation we had is x plus 3 y equal to 300, and the second equation we had is x plus 4y equal to 600. Remember, now we need to solve them. Any method we can use because they are not mentioning particular method here. So let us solve by using elimination method. I am going to subtract equation 1 from equation 2. Yeah, so let us write in order to do that. X plus 4y equal to 600, and first equation is x plus y equal to 300. Now we are subtracting. So changing the signs for everything, x cancels. 4y minus 1y will be 3y. 600 minus 300 will be 300. Right? So that gives us y equal to 300 divided by 3. That is 100. Okay. And now we need to use this value of y in the first equation or second equation, whatever, to find the value of x. I am going to use the first equation because that is much simpler, right? So using y equal to 100 in equation 1, x plus y equal to 300 implies x plus 100 equal to 300. That implies x equal to 300 minus 100. That implies x equal to 200. So always we have to give a statement conclusion, right? Here, therefore, number of chairs rented by the school is 200, and number of tables rented by the school are 100. Let us move on to the next part. Part B of the same sum. If the school wants to spend a maximum of rupee 27,000 on 300 items, totally tables and chairs, then find the number of chairs and tables it can rent. So now the second equation has got a change, right? So now we have to recreate new equations and then we have to solve them. Okay, so total number of items rented is the same 300. So x plus y equal to 300. There is no change in that. Let us call this equation 1. But the school is spending 27,000 rupees only right now. So for that what we have to do is we have to write the equation for that. So 50 into x, because x chairs they are renting for one chair the rent is 50, the same scenario only, right? And for one table the rent is 200. So for y tables it is 200y, but the amount they are going to give this time is only 27,000. Okay, so now we have to divide the second equation with the 50 as usual. Divide by 50 throughout. We are having x plus 4y equal to 540. So we are calling this second equation. Now the same way we have to solve both of these. Okay, let us do that. Here also I am planning to do subtraction only. X plus 4y equal to 540, and the first equation is x plus y equal to 300. Subtraction only. 3y on the LHS, here we will get 240. Okay, so y equal to 240 divided by 3, which is 80. Now if we put this y value in equation 1, using y equal to 80 in equation 1, we get x plus y equal to 300 implies x plus 80 equal to 300. That implies x equal to 300 minus 80, which is 220. Okay, now let us write the statement conclusion. Okay, that's the end of the sum. Let us move on to the next part. What is the maximum number of tables that can be rented in rupee 30,000 if no chairs are rented? Okay, so this is very easy. Actually, they are not renting any chairs at all. So only tables with all the 30,000 rupees. Okay, so what we can do is rent for one table is the same rupee only, rupee 200. Therefore, rent for y tables will be 200 y. Now all of these total rent is supposed to be equal to 30,000, right? Therefore 200 y is supposed to be equal to 30,000. So only tables are rented, right? So y equal to 30,000 divided by 200, and this will give us 150. If you are not renting any chairs, only tables are rented, it can be possible for 150 tables, right? So therefore, okay, so that's the end of this case study. Let's move on to the next one. Sum 37. Rahul is a lucky charm for his cricket team. He has a jar of cards with numbers from 10 to 74. Before each match, he draws a card from the jar. If the card bears an even number, the team wins. If the number is even and divisible by 5, they win by a big margin. If the number is an odd number less than 30, they win by a small margin. And if the number is a prime number between 50 to 74, they lose. So, answer the following questions if Rahul draws a card today. So, one thing we have to understand is they have some belief, right? So, that guy, whatever number he draws, will tell their fortune, right? So, let us see. So, what this guy draws, whatever number this guy draws, if that number is an even number, then they are going to win the match. Okay, and also if that even number and that is divisible by 5 also, then they will win by a big margin. Big margin means they score a lot of runs. If the number is an odd number less than 30, whatever number this guy draws is less than 30 and an odd number, then they will win, but not so great gap between the scores, right? Very less margin they will get. And if the person is drawing a prime number between 50 and 74, then preferably they'll lose in the match. Okay, so let us see what all the questions we are going to answer. Number 1, what is the probability that Rahul draws a card with an even number? Always we have to write the sample space whenever we are solving some probability related sum, right? That is a good practice always. So S equal to the sample space equal to start from 10 and then write all the possibilities 10, 11, 12, etc. up to 74. They have cards in the jar. Okay, how many cards will there be in total? That also we have to tell them, right? So how can we find it? Yeah, no need to count one by one. Okay, that is waste of time. So what we can do smartly here is, if I had 1 to 74, I know there will be 74 cards, right? But only from 10 we have now. So cards from 1 to 9 are not there. So how many cards are not there? 9 cards are not there. So out of the 74 cards, 9 cards are not there. Total number of cards available in the jar will be 74 minus 9, that is 65. So there are 65 cards between 10 and 74. This is one way of doing. If you are confused doing this way, you can use the AP's techniques also, because 10, 11, 12, etc. 74 is an AP with the first term 10 and the common difference 1. So you can find how many terms are there if the last term is 74. Yeah. So if you take Tn equal to 74 and find what is that n, that also will give you 65. That is another way of doing the same thing. So this is very basic thing, right? We can easily do this way, right? So now we have found n of s equal to 65. Okay, now the set of even numbers we have to list down. Okay, so let E be the set of even numbers from 10 to 74. Okay, how many even numbers will be there? Let us write them. Starting from 10, 12, 14, etc. It ends up with 74. Okay, so here also we can use the same technique. Okay, so from 1 to 74, number of even numbers. How can we find the even numbers? See, there is alternatively even and odd numbers coming, right? So for example, 1 is an odd number, then the next one is even. 3 is an odd number, then the fourth is even. So alternatively, even and odd will show up, right? So based on that, we can tell that out of the 74 total numbers, half of them will be even, half of them will be odd numbers, right? So what is half of 74? It will be 37, right? So 37 even numbers will be there if we had numbers from 1 to 74, right? But we don't have 37 even numbers now. So what are the even numbers from 1 to 9 which are missing here, right? Because we have only from 10. So from 1 to 9, the even numbers list will be 2, 4, 6, 8. So from 1 up to 74, it is supposed to be 37 even numbers, but these 4 even numbers are not counted in this. So how many numbers will be there in E now? N of E is equal to 37 minus, there are 4 numbers missing. So if we subtract, we will get 33, right? This is an easy way to do. Even otherwise, if you are confused doing this, you can apply again AP techniques to count the number of terms in this AP. This AP has the first term 10 and the common difference 2 and the last term 74. The same way you can find how many terms are there in this AP. That will help you to find the number of elements, which is 33. Yeah, so same answer only will come however way we do. So n of s is here, n of e is here. Now we need to know what is the probability of drawing an even number, right? So probability of drawing a card with even number is equal to n of e divided by n of s. That is the formula for finding the probability, right? That will be equal to 33 divided by 65, and we can't simplify this, so leave this way. That's the answer. Okay, now let us move on to the next part. So in part 2 we have what is the probability that Rahul draws a card with an odd number less than 30. Okay, so again we need the sample space, the whole options available 10, 11, 12, etc. up to 74. No need to count, we are already having the count in this, 65 numbers are there. And odd number less than 30 we have to think about. Okay, let us call this event like E1. Okay, E1, everywhere I am changing this to E1. Okay, now I am going to call this event like E2. Okay, let E2 be the event of drawing a card with an odd number less than 30. Okay, so how many favorable outcomes are there? We need to write here. So less than 30. Okay, start from 10. So 11 is the first odd number, and then 13 and 15, 17, 19, 21, 23, 25, 27, 29. Since the number of items are very less only, we are writing the full set here. So n of E2 is equal to 10 here. Right? We can easily write them also. We can easily count them also. So n of E2 is here. So therefore, probability of drawing a card with an odd number less than 30 is equal to n of E2 divided by n of s, which is 10 divided by 65. Here we can simplify this with a 5. 5 2 times and 5 13 times. So 2 by 13 is the probability for drawing an odd number less than 30. Okay, now let us move on to the next. Option 3 has two choices. The first one is, what is the probability that Rahul draws a card with a prime number between 50 and 74? Okay, so we need to write yes again as usual. 10, 11, etc. up to 74, and the count of total available items in this is 65 as usual. Now we are going to define another event, which is E3. Let E3 be the event that Rahul draws a card with the prime number between 50 and 74. So we need to list down what all the favorable outcomes for this event. Okay, so now we know that 53, 59, 61, 67, 71 and 73 are the prime numbers between 50 and 74. Okay, so now how many entries are there in this? Number of items in this are 6. Okay, therefore probability of drawing a card with prime number between 50 and 74 is equal to n of E3 divided by n of S, which is equal to 6 divided by 65. And of course we can't simplify this, right? That's the answer. And the other part of the same sum is, what is the probability that Rahul draws a card with an even number divisible by 5? So basically we need to write the 5's multiples which are even. Okay. So again we need to write the set S as usual, 10, 11, 12, etc. 74. And the count of items in this is 65. And again we are going to define another event here. Let E4 be the event that Rahul draws a card with an even number divisible by 5. Okay, so how many favorable outcomes are there for this event? Let us count them. See, the number should be divisible by 5. At the same time, it should be even also. So, we can't take 15, 25, 35, etc. because they are multiples of 5 and odd numbers. So, skip all those. Only the even multiples of 5 we have to list down. 10 itself is an even multiple of 5 only. Then 20, 30, 40, 50, 60 and 70, right? So number of items in this set will be 7 items. Okay, therefore probability of drawing a card with an even number divisible by 5 is equal to n of E4 divided by n of S, which is 7 divided by 65, and this also we can simplify, leave it this way. Okay, so that's the end of this case study. Let us move on to the next one. This case study is based on surface areas and volumes related sums. A skilled carpenter decided to craft a special rolling pin for the local baker. He carefully joined 3 cylindrical pieces of wood, 2 small ones on the ends and one larger in the center, to create a perfect tool. The baker loved the rolling pin as it rolled out the smoothest dough for breads and pastries. Okay, so that rolling pin the person is holding, the dimensions of that are mentioned in this diagram. So seeing this, we can say the bigger cylinder in the center is having a height 12 centimeter and a diameter 7 centimeter, right? And then to hold it, there are 2 same sized small cylinders attached to the ends. Okay, their dimensions are given like 5 centimeter is the height and 2.1 centimeter is the diameter of both of them. So this is the information they have given in the statement below this also. The length of the bigger cylindrical part is 12 centimeter and the diameter is 7 centimeter, and the length of each smaller cylindrical part is 5 centimeter and diameter is 2.1 centimeter. Based on the above information, we have to answer the questions following this. Okay, so first one, find the volume of the bigger cylindrical part. Okay, so this is the bigger cylindrical part, right, whose volume we need to find out. Since there is a bigger cylinder and a smaller cylinder as well with different dimensions, we have to take their particular height and radius with the variables assigned. Okay, let capital R and capital H be the radius and height of the bigger cylindrical part I am taking. Okay. Volume of the bigger cylinder we need to find out. Therefore, volume of the bigger cylindrical part is equal to pi r square h is the formula, right? But r and h we have to use the capital letters. Okay. So, pi r square h. Centimeter cube will be the unit for the volume, right? So, we have written that also. Now, let us put the values given to us. And about the radius, we have to find it only the diameter we are having, right? So, r equal to diameter divided by 2, which is equal to 7 by 2. I am not going to convert it as a decimal. I am planning to keep it as a fraction only, because fractions are more easier to handle than the decimals. Okay. So, let us do the calculation now. Pi is 22 by 7 and r square means 7 by 2 twice. So, 7 by 2 multiplied by 7 by 2 and height is 12. Okay, so we need to simplify this. Let us cut this to 7s and 2 6 are 12 and 2 3s are 6. So, we are ended up having 22 into 7 into 3 and we need to multiply these numbers. And the product of all these numbers will be 462. So, the volume of the bigger cylindrical part is 462 centimeter cube. Okay. So, that's the end of the first sum. Let us move on to the second one. Find the curved surface area of the bigger cylindrical part. So, we have already named them like R and H. Okay. Radius equal to capital R equal to 7 by 2, the same only, and height equal to h equal to 12 centimeter for the bigger cylindrical part, right? Therefore, curved surface area of the bigger cylindrical part is equal to 2 pi RH. Remember, it is 2 pi RH. R and H are in capital letters. We have used like that. So, the unit will be in square units, right? So, centimeter square. And let us put the values we have already kept ready. So, 2 into 22 by 7 into capital R is 7 by 2 and capital H is 12. Now, let us try to simplify. 7 is cancelled. These two 2's are cancelled. So, we are ended up having 22 into 12 and the answer for this is 264 centimeter square. That's the end of the second part. Now, let us go to the third one. Third one has two choices. The first one is find the ratio of the volume of the bigger cylindrical part to the total volume of the two smaller identical cylindrical parts. So, bigger cylindrical parts volume is already ready with us. Okay, we have already calculated it in part 1. But the smaller cylindrical parts total volume we haven't found yet. So, we have to do that now, right? So, let us assign the variables because we haven't done that also. So, let us do that, okay? So, let small r and small h be the radius and height of both the smaller cylindrical parts. Okay. So, what is r here? The diameter is 2.1. Okay. So, radius will be half of that. So, 2.1 by 2 centimeter. I am not going to convert it also. Okay. And height will be 5 centimeter. Now we need to find the total volume of both the smaller cylindrical parts. So we will find one of their volume and we will multiply that by 2 because both of them will have the same volume because they are identically similar figures, right? So now let us do that. Volume of one smaller cylindrical part equal to pi r square h is the formula as usual, centimeter cube. So that will be 22 by 7 into 2.1 by 2 into 2.1 by 2. R square we have to put and h is 5. Okay. And if required, we can write this 2.1 as 21 by 10. Okay. So let us do that also. 22 by 7 into 21 by 10. 2 is already there in the denominator. So this will be like 21 by 10 into 2. And the same way the next one also 10 into 2 into 5. So this can be written like 22 by 7 into 21 by 20 into 21 by 20 into 5. Okay, now we can try cancelling things. So 7 3 times we can cancel here and 5 1 time, 5 4 times 20 we can do and 2 2 times and 2 11 times we can do, but rest of the numbers we can't cancel here. So we are left with 11 3 21 in the numerator and 2 and 20 in the denominator. Let us continue. So let's do that. So the product of 11, 3 and 21 will be 693 and the product of 2 and 20 is 40. Now let us try to simplify this also. So the answer for this is going to be 17.325 centimeter cube. Okay, this is the volume of one smaller cylindrical part only. We need to find the volume of two of them. So therefore volume of two smaller cylindrical parts is equal to 2 times 17.325. That is going to give us 34.65 centimeter cube, right? So volume of both the smaller cylindrical parts are here and volume of the bigger cylindrical part also we have already found and kept, right? That we can write here. Also volume of bigger cylindrical part equal to 462 centimeter cube, right? Now let us see the question. Ratio of volume of the bigger cylindrical part to the total volume of two smaller cylindrical parts. So that we are going to do now. So bigger cylindrical parts volume is 462 is to the two smaller cylindrical parts total volume is 34.65. Okay, so we need to convert it as a ratio, but before that we can convert it as a fraction so that the calculations are easier. Okay, and we need to multiply by 100 and divide by 100 so that this decimal dot is removed, right? So this is 462 by 34.65 multiplied by 100 by 100. So the numerator will be 46,200 divided by the denominator will become 3,465. Now we need to start simplifying this. So this is like 3080 divided by 231. Again we need to write it as a ratio, right? So this is 3080 is to 231. This is the ratio of their volumes. Okay. So now let us move on to the second subpart of the same thing. Find the sum of the curved surface areas of the two identical smaller cylindrical parts. Same way, we will find one of the smaller cylinders curved surface area and we will multiply that by 2 because both of them are identically similar. Okay, so we have already mentioned about the variables in the previous subpart itself, right? So curved surface area of one smaller cylindrical part is equal to 2 pi r h, right? We can mention what is r and what is h, that is not a problem. R is 2.1 by 2, or we can write it like 21 by 20 like we have done earlier. H is 5 as usual. Okay, now let us continue with the calculations. 2 into 22 by 7 into 21 by 20 into 5. Let's try to simplify this. 7 3 times and 5 4 times and 2 2 times and 2 11 times. So we are having 33 centimeter square as the answer, right? This is CSA of one smaller cylindrical part and they are asking sum of the CSAs of both the smaller cylindrical parts. So we have to multiply this by 2. Will be equal to 2 times 33, which is 66 centimeter square. Okay. That's the end of the paper. Thank you. Hope this video was really helpful for your revision of concepts. Do share this video with your friends. Please stay tuned because we are going to solve many previous year papers together. Until we meet in the next video, happy learning!